Okay. Audible again? Okay. So we have been talking about a lot of technical stuff till now, right? So what I thought was, let's do a little different. As she gave a nice introduction about myself, right? So thanks to the AWS Club team for inviting me to talk here, and thanks to St. Joseph again. So we'll kind of go through. Let's say, what I wanted to do is. Oh, sorry. Yeah. Uh, Let me talk about a little about myself, right? So I've been in IT industry for 12 plus years now, and I have a privilege of working from the core, if I have to say. Let's say that's what I'm going to go through today, so that it's not going to be the technical stuffs, etc. It's going to be more of let's say learning about the history of serverless and the dev tools, right? So I think that's the basic that we don't understand, and what it actually means to us, right? So what are these tools and what these tools means to us is what I'm going to go through today. And yeah, I have, as I said, 12 years of experience, starting with the physical and then ending up with serverless, writing a lot of code, automation codes in different types of languages, programming languages, etc. So I think it's gone again. Hello? Thank you. Yeah, and I've been doing a lot of trainings as well. So it's been 6 years that I started training students, training people, training not only college grads, but training across from the students level, from schools to colleges to even IT people, right? So I go through a lot of technical and non-technical trainings. In terms of non-technical, I go through the mental aspects of people, right? So that's very important. Again, we know all technical things are there, but the physical and the mental is equivalent, right? So we call it as work-life balance in IT, right? So that's what I try to do, right? And yeah, and then been talking forever, and you will see me talking for the next 30 minutes or so, right? So this is what I want to go through: a crawling baby to a grown-up or a growing-up kid, right? So how the technology has evolved, right? So evolution is everything, right? So we know that humans have evolved from monkeys, right? Similarly, technologies have grown from the base to serverless or the dev tools that we use right now. So that's what we are going to go through. I'm going to kind of put some pictures here. Probably the next thing. Multiverse. Seems familiar? The word? Yeah, Iron Man again coming up, right? So we have kind of 3 kinds of world within our world itself, the IT world itself, but it is correlating, coexisting. Without this, we will not be there, right? So the first world is the physical world itself, right? The second world is the VMware world or the virtualization world. So I call it as VMware world because they were the pioneer of the virtualization itself, right? But the third world and the most important world is the cloud world that we are currently living in, and AWS is kind of pioneer in that, right? So we are here to learn about this journey. Okay, again, I'm going to put some pictures. Any guessings, would be good. Okay, what do you think this picture depicts? Sorry? Yeah, it's a warehouse, it's a data center, right? What is this? Servers or? Yeah, server room or the rack servers, right? Yeah, what is this? This is a server or single rack. What is this? What is this called? CPU. What is this? RAM. I'm glad that you guys are knowing these things. When I started, I did not know, to be frank, right? So this is how the physical world looks like, right? So thinking about this makes me feel this, really. I'm drained out, right? I was drained out seeing all these things 12 years back, right? Why? Because I have lots of things to think about, right? For example, if I am let's say I am a company who's going to set up 10 years back, 12 years back, I'm going to set up a new company. What I do is I'll have to think about all these things. 1, 2, 3, 4, 5, 6, 7, 8. It goes to infinity, right? It doesn't end here actually. I wanted to, I did not have space, by the way, right? So that's the difficulty of physical world, right? So, but does it exist? Yes, it does. In AWS, it does. In GCP, it does. Microsoft, it does. But we do not know it. That is all that the difference that it makes, right? So that is what the physical world was, right? Or the world was before 10 years, or even it started around 1996, if I'm not wrong. The cloud technology, the cloud computing, the word itself, right? So it started around 96. We have come, what, 25, 26 years now, or 30 years now, right? So we have evolved a lot, but trust me, last 3-4 years was the real evolvement of these technologies, right? So that's where we have been kind of lucky. The Gen Z group, right? The Gen Z group, we call it as Gen Z group, right? So we have been lucky in terms of learning this technology as fast as possible. We did not have that option to do that. We were slow. Our environment was slow, but currently it is not like that, right? So I am not, I'm recharged now. I'm not out of battery now, right? Now, when I go, usually, right? So back those days, when I go to my office, right? I go and sit. Back then, you do not have a laptop, by the way. Okay, they don't give you a laptop unless you are a lead or a manager or whatever the highest post that you have, right? So you'll have to go to a desktop and sit there and open your computer. Okay, what do I see first, right? So first thing that I'll have to do as a fresher was to open this prompt or open this UI, which is a alert manager UI, right? I'll have to see everything is green or not, okay? That nothing should be there in the red portion of it, right? So if I have to tell this one, right? Because if it is red, then you are dead. That is what it is, right? And if it becomes red, what happens, right? Yeah. What I have to do is I'll have to raise a ticket and say so and so server is down, and I'll have to kind of wait for the response. Who's behind this? So I'll have to raise a response to or a ticket to data center admin, who's actually sitting somewhere, right? The data center farm picture that you saw was in Mumbai. That's the AWS data center farm, which is located in Mumbai, right? So similar to that, I'll be in Chennai. So we'll have to open a ticket to a guy in Mumbai, right? And we'll have to wait for him to go there and check that particular server. Like that was the case. And trust me, it'll take minimum of 1 week to do this, right? Minimum of 1 week, because you need to log in a ticket, you need to assign a particular employee to it. He has to go there all the way. The farm will be not in the city, it'll be outside city, right? You need to travel. So all these things were difficulty, right? And that was a real pain in the ass, right? So what happens? After a week or 2 weeks, I'll be okay, fine, we'll sit. Then again, plong, there's another email, alert, oh God, again, 2 weeks of time. That's how it was, right? So what we thought, or what the industry thought, the leaders thought, right? Why not we do the next step, which is the virtualization world, right? That's when, the virtualization stepped up, the technology stepped up, and they started to make it, in terms of not knowing it, right? So you don't know it. So you still have it, but you still don't know it. So they started off with hardware, storage, network, and server virtualization. So there are different types of virtualizations, but this was the start of it, right? Because these are the 4 components which will be like the main or the basic components of your day-to-day life in terms of IT, or in terms of your professional work, or in terms of your let's say day-to-day work, right? So you see different virtualization. Do you see any of this being used in your day-to-day life? No? Which one? Yeah, yeah, network virtualization is there, yes. Okay. Which term does it sound familiar to you guys? Application. Okay. Can you give me an application virtualization? Docker. Okay. But real-time use case? Any real-time use case? Think from user perspective. Your mobile phones, apps that you use, the games that you play, right? Everything is application virtualization here, right? So it is running at the back end on a Docker or on a server or on any other platform. But as a user, what do you know? It's just an app to play. It's just a game to play, right? That's how we developed. That's how technology evolved, right? So that was very important that the evolution was, let's say, a little slow in terms of moving from physical to virtual. And I still remember I worked with VMware for 10 years. So I started my career with HCL, contracted to VMware, and as I said, VMware was a virtualization giant. And I still remember back in, if I'm not wrong, 2014, 15, and we had virtualized the database server, the EBS database server, and it was like somewhere around 5 TB or 5 TB of data in that particular server, and we called it as a monumental effort. Trust me, 5 TB of data, monumental effort. But right now, what do we have? 5 TB of hard disk everywhere at home, don't we? Yeah. So that is how the evolution is, right? So that's how fast the world is now growing, and you need to be with the pace of the world, right? But saying that, you guys are having a wonderful opportunity here, so make use of it and then move forward, right? So these are the examples, and as I said, these 4 are the ones which actually came in first, right? Okay. Now, is my problem solved? There will be always problems, right? There will be always problems that has to be solved, are there to be solved, etc., right? So what was my next problem, right? I still had to kind of sit, do work, in terms of manually doing it, etc., right? So this is what VMware actually came up with, or virtualization, if I have to put it across as virtualization, had to come up with, right? So what we did, or what they did, was the physical servers, right? So the concept remains the same across your virtualization world, right? It will be similar to hypervisor, which will be installed in your physical machines, and that will allow you to do all the virtualization. So virtual is just not there. That's all. It's a simple term. It's just not there, right? So on top of your physical servers, we install let's say a software, and then on top of it, you will have OS and app installed. For example, your OS and the app could be your simple mobile phones, right? Your laptops, right? That can also act as a server or also act as an application medium. So we just saw that we could host our application in the previous session, right? So that's what virtualization gave us, right? Now, as I said, did it solve the problem? No. What do you think this picture is? What am I trying to convey? Multitasking, yeah. I think you would be familiar. Yeah. Anybody else? What do you think this picture might be? Overworked, yes, right. Any other term? Stressful, yes. Again, any other thing that comes up? Okay. This is just a deployment on a Saturday morning. What happens is, typically the guys who's doing the night shift on a Friday night is the is the baddest feeling of everything. I think you would have gone through it, right? So, what happens? Saturday morning is our deployment date, right? So typically our releases, our production codes, our new applications, etc. in our term, right? So goes early on early on Saturday, right? So what happens is, what I am trying to depict is, we will have at least 3 releases going on parallelly. 3 releases, and we will have only one admin. So only one admin to take care of 3 releases, right? And that is depicting a picture where I have a desktop and I have 3 or 4 desktop phones which is surrounded by me, and I'm on call on each of the phones. They'll call, Ashwin, where are you? I'm on another call. Just give me 2 minutes. I'll come back, right? That's how we used to work. That's how the deployment used to work, right? It was hectic. It was very stressful. And it was like, why do you have to work? It was such a kind of, stressful environment to actually work, that is only on a Saturday morning, right? So it'll be very tough, and it was very tough, right? So that's when we thought, okay, this is the end picture after the deployments, okay? So we'll just sleep off, okay? Yeah. Now, what did we thought about? What is the next evolution that came in? Is automation, right? So we tried to automate a lot of things, right? So automation in terms of, it was spread across the region, or spread across the technology. It might be infra, it might be your app, it might be your database, it might be your X, Y, and Z, right? So everywhere you can automate. There's no place that you cannot automate, right? Except the physical, but yeah. That's where the automation was very key for us, right? So what we did usually is to automate end to end. So we called it as no touch deployment, right? Where we don't have to kind of, just click like this. Yeah, the same picture, right? I wanted to do this, but I could not do this, by the way, right? So this, I thought, okay, at least I will have the picture of this saying, this is how I wanted it to be, right? So automation end to end, no touch deployment actually saves a lot of time. It's reliable, less human error. So you will not be feeling that, so there's a feeling, always a feeling that, computer doesn't do mistakes, right? Except for the ChatGPT 27 number, okay? But apart from that, the numbers are really consistent, right? So that is what we thought, and mainly it covers this one, frees up the frying brain of the human brain, right? So you don't need to again and again do the same thing, again and again do stuffs which is like day-to-day activities. These releases are day-to-day activities. All those things were kind of hectic, and yeah, it was turning our brains into, let's say, if you even go home, if you sleep and then your mom wakes you up, it's like, PyChat from Python from, oh, sorry, you're at home. Oh, sorry. Yeah, that's how it was, right? So we were too fried up to actually do it, right? So yeah, how did we do it initially, right? So the automation strategy was to, we had cron jobs, we had schedulers which will actually do that for us. But yeah, the downside of that was you need a server always running for that, right? So you do an automation, and you do an automation, and it is like something where there should be a server which is running, right? Without that, your script will not run. Without that, nothing will communicate, right? So that was the downside of it. And then also the runtime. So we were talking about runtime in the previous session also, right? Runtime was very important. If your runtime is not there, then there's a problem, right? So to address all these problems, AWS came up with a solution called serverless function, right? So these are different serverless functions which is actually there, which actually helped us to kind of orchestrate our job, orchestrate our automation, right? Lambda. How many of you have heard about Lambda? Good enough, right? Okay. Event Bridge. Okay, nice. DynamoDB streams, probably S3 is common. DynamoDB streams, okay. SNS, SQS, okay, good enough. Yeah, so it's just a combination of all the tools that we have. See, automation is all about how do you combine your tools together, right? So once you have the vision, you combine the tools together, then it will become your automation. So automation is always in your hands, just that you need to have the right mentality to do it. And AWS had the right mentality to do it, and they gave us with all these tools which will actually help. So just an example, right? So a developer who develops a code, right? He pushes that code to AWS code commit. I'll come to AWS code commit in a bit, right? And then the code is being built using a pipeline, which is AWS code pipeline, right? And then it uses Lambda function to just run the code on the servers. So what it is doing is, this particular function doesn't need a manual intervention. All that it has to do is it has to have a scheduler which will actually kind of schedule a Lambda function to be invoked, and then the Lambda function will actually run that particular code. So if you see this, I have two codes, right, which is written, and you just have to put that code inside the Lambda function and it will automatically work. So that's how it evolved, right? And for this you can also use the other things also. So this is an example for let's say the other ones, other examples, right? So event is like an event, right? So we are having an event now, right? Similar to that. So anything which happens on a system is called as an event. As simple as it is, right? Anything which happens on a system is an event. You log in, it's an event. You type a command, it's an event, right? All these are events. So event bridge is something which will conduct your or orchestrate your automation, right? So that's what it does. So this is an example for SNS and with DynamoDB. By the way, DynamoDB is nothing but if you write something on the DB, particular DB, right, and it will automatically trigger you an event. So that's what it does. So that can also be used. So that's what I was saying. It can be across the technology. It is not restricted to app. It is not restricted to OS, infra, etc. Right? So the automation can be across the technologies, and AWS provides us with that. Right? Now, okay. Last thing. Okay. Have you been in this situation? Yeah? I see a lot of smile. Yeah, I have seen. Yeah, initially, yeah, 10 years back, I was in the same situation where I used to write a code. My first line of code or the first automation code that I wrote was for 600 lines. I didn't know that it can be done in 4 lines also, but I wrote it for 600 lines without knowing that it can be written in 4 lines, right? Yeah, what I did was, after writing that code, and the next day morning I had to kind of test it. What did I do? I came, I logged into the machine and see that it is not there. The 600 lines of code is not there. Okay, what happened? I went through the user logs and saw somebody had deleted, because I think I had named that script as some catch temp.sh. Okay, so seeing that word temp, somebody deleted that. Okay, the 600 piece of code, 600 lines of code. So that is how we were. That is how pathetic we were, right? So that is when all the other factors came in, which is these things. The dev tools, code commit, right? Heard about code commit? Git, GitHub. Yeah, that's similar to the code commit, right? Code build. Code build? Anyone? Okay. It is just going to build your code. Okay? Whatever you are writing, it is going to build your code, right? And then code deploy, which is the function which will actually deploy it to your servers. That deployment I was talking about, 3 deployments per night, sitting on the Saturday morning, early morning, 7 o'clock, 6 o'clock, after the night shift. Yeah, those things, right? And then code pipeline, which will actually kind of orchestrates the everything. It's a flow, right? It orchestrates all the flow, and it will put into a pipeline, right? And then Cloud9. Yeah, so this is an example of how it could be. Yeah, it is just an example, right? So it is all about orchestrating, it is all about designing, it's all about how do you want to. So I just want to conclude by saying, yeah, from the, we have just gone through in, let's say 20 minutes or so, 20-25 minutes, like how tough it was to how easy it is right now, right? So that's how the technology has developed, that's how the technology has grown, right? That's how AWS has grown, to be precise also, right? I always thought, why did the term called cloud computing, why did they term it as cloud computing? Any guesses? Any guess? Huh? Yeah, access from anywhere, right? So the first thing that it came up to my mind is probably the inventor of that name, right, was outside his house and was seeing in the cloud, and he could not find where is the cloud, right? So yeah, that's why it is cloud computing. So your guess is as good as mine. I did not know. They did not know why it is, because it is referenced in 3 or 4 places saying cloud computing, and I don't think so they will know who has actually coined that term. So funs apart, jokes apart, right? So all these dev tools of all the serverless configurations are very helpful for us. And if you actually do it in the right way, like I showed in this piece of let's say 20 minutes of presentation, if you guys actually take it up, it'll be very good. Thank you guys. Thank you. Any questions?
Yeah,
I don't know.
are there any questions? No, right? Thank you.
Thank you.
Yeah.
Thanks.
Caller,
Yeah.
sorry.
Sorry. Yeah.
Yeah, thank you so much, sir. Sorry. Thank you so much, sir, for that. Okay, thank you so much, sir, for that inspiring session about deployment and various AWS services. Next, we have with us Mr. Mandeep Singh, who will be taking a session on the topic Making DynamoDB Work with Us, a playbook of production patterns and pitfalls, where we will look into the patterns that scale and pitfalls at the best practices that lead to reliable and high performance systems. So, onto the stage, I invite Mr. Mandeep Singh. Yes, sir. Oh, that issue. Yeah, MacBook and this thing, it don't comply, so they need a intermediate. Call the other guy.
Try this one.
Yeah, sure, this is my phone. It's working, right? And sir, may I put this on your collar?
Yeah.
Okay.
And that remote, I have
Yeah,
to.
1 second. Where's the remote? Will it be plugged?
I don't know if USB is not here, but. I don't know.
Press the key of immediate right shift.
Should I connect the laptop there directly? And
Okay,
I can.
wait 1 second.
What is that you're trying to achieve?
trying to connect this to the laptop.
Oh, this is a Mac, right?
Yes.
Okay. Windows is very easy to connect. 1 second.
If you have Windows laptop, you can keep my slides
Do
there.
we have one more laptop?
Can we use your laptop for the
Yeah,
slides?
no, I'll put that. Yeah, you're not able to change it?
No, he's not able to connect this.
No, there was a pop-up, right?
Yeah, the pop-up is not.
We have connected that here.
One sec. Where is that? Will it come up?
So we have a Windows laptop.
Okay.
I think that's better.
Yeah, thank you.
No worries. It's just a
Should be.
Do you have slides on that?
It's always like
yeah, that's okay. That's okay.
For the next paper, we'll keep this already.
Yeah, that will be.
Okay. See, if not, you use my laptop. It just came up, right? It should have come up again.
No problem. We can connect in that way.
Yeah.
Laptop.
Yeah, sure.
Okay, let me try. I'll try this.
Please share those slides. You have shared it?
Yeah, I did. I changed a little bit, but I updated again.
Okay. Then it should be showing up there.
you've got your adapter.
No, Akka, but we have that speaker.
Is it okay if you can like share the slides to your email and then
Actually, we have the laptop. No, this we got.
it's okay, sorted.
It is sorted, but now we are changing it from Mac to Windows, so it will have time control. The Windows side is seamless. Sir, it's sorted.
Yeah, I think you should be able to use it now. Where is your
What?
slide?
Slideshow.
Yeah, slideshow. Put it in slideshow. Just one sec. Can you try?
Where is the remote?
Here, may I try?
Down.
Yeah, it's
down.
Okay, it's work.
Thank you so
Great.
much. Thank you so much, sir.
सही टाइम पे याद है.
You need the water, but we can keep it on the.
Yeah. Cool. So, sorry for that, all the mess up we did. Let's get started with the session. So, the title of the talk is Making DynamoDB Work for You. You have been listening a lot about AI, agents, generative AI, artificial intelligence in all the sessions, and there is a separate track going on. There are a lot of sessions around it. We will take a break from that, and we will be talking about efficient data storage for time being for next 30 minutes or so. So the title of the talk, as I said, is Making DynamoDB Work for You, the Production Patterns and Pitfalls Playbook. So it's an amazing technology offered by Amazon, and it is used for data storage. So since you all are part of AWS community, I'm assuming that you all have heard about Amazon DynamoDB. What I will be doing is, what are some critical things or key things we should keep in mind so that you can make best use of this particular technology, and what could be some pitfalls, what could be some scenarios where you should not use Amazon DynamoDB. So we will be discussing that as well. Let's get started. And before I go further, I will quickly introduce myself.
No, down.
Okay. Yeah. So about me, I'm Mandeep Singh Shekhawat. I'm a software engineer with around 7+ years of experience. I'm also author of a book called System Design on AWS. It was published recently. I also brought up 2 copies with me, so it's in the Cloud Club library. So if you are a student of this college, you can check that out. I'm also a AWS community builder, so that's how I got to know about this conference, and I'm part of it. I also run a YouTube channel called Deep Singh. So if you love system design and are interested to explore cloud architectures, you can check out that as well. Now, before we start with any technology or like any solution we see, like previous session was also around that, like how you came up with the serverless, why serverless came into existence. So that's how we will start with this session as well, like why DynamoDB came into existence on the first place. So we will start with why NoSQL exists, why non-relational databases exist. Now there is no perfect definition for NoSQL databases. It's just that the database which is not a relational database, which is MySQL or PostgreSQL or anything, is called non-relational database or NoSQL database we call it. Now what I will do is I will take some differences between relational and non-relational databases, like when it first started, why this technology came into existence at the first place. So these are some differences, and note that these differences might not hold true but at the current time, but they were true when first non-relational databases came into picture, and there were different solutions, Hadoop, and like you can remember around that time. So for first thing is, like whenever you see there is a requirement for transactional workloads, I want to see, let's say I say that I want to use ACID properties as atomicity, consistency, isolation, durability. Now on those scenarios you tend to use relational databases. For non-relational databases, it is mostly what comes to my mind is there is a big data involved. There is a huge data set, and for those use cases I want to use non-relational databases. Second thing is normalized data. In case of relational databases, what I try to do is I try to avoid duplication at any cost. So since you are again part of college, so you have this recently in mind that there are different normal forms, 1NF, 2NF and all those. So in case of relational databases, generally the data is stored in normalized form. And in case of non-relational, it is in a denormalized form that you try to dump all the data at a single place. Third point being joins. Now since you have data which is separated into multiple tables, you will need joins. Okay. Now in case of non-relational data, you will no longer need that because data is already at a single place. And the final point is which is very popular, that people say that I want to use a non-relational database because it offers horizontal scalability. And in case of relational databases, it is only scaled vertically. That is again not true at this current moment. You can always scale the horizontally relational databases as well, but that's how all the things started. Okay. Now let's introduce what's the new service, like what's the service which is offered by AWS, which is Amazon DynamoDB. So Amazon DynamoDB is a non-relational database offering. It is a document and a key value. You can store these kind of workloads here, and it's a fully managed, when like we are in a serverless track only, so you don't have to do anything. AWS manages everything. When I say fully managed, you don't have to worry about server nodes, you don't have to worry about operational overhead. There is a less to zero to minimal operational overhead there. So that's there. And one critical thing which is offered by Amazon DynamoDB is you can always say that there is a predictable latency at any scale. When I say this, what I mean is that whatever your request is, let's say you are just starting out with your application, you are just launching your startup, so you have around 10 users. After scaling, you have, let's say, 1,000, you are reaching to 1 million. So you can always expect DynamoDB to deliver at that scale. You can always say if my application is performing at 10 seconds or 10 milliseconds, 10 seconds is pretty huge. If I say it is always performing for 10 milliseconds, then it will always be doing that at 1 million scale as well. So this is a pretty good feature which is offered by Amazon DynamoDB. If I quickly talk about the storage part, so we will be going through some of the basics, and then we will jump to the production patterns. So the first thing is how the data is stored. Now you know what DynamoDB is, what are the some of the functions or like features which are offered by AWS for Amazon DynamoDB. So the first thing is how you will store the data. The data is stored or uniquely identified with a primary key. Primary key is nothing but a combination of partition key and sort key. partition key is your mandatory, which identifies where the data is landed, and sort key is optional key. So let's say if I do not specify sort key, then partition key should be unique across all the entries. If I specify them both, then the combination should be unique, and the combination of both of these keys is also referred to as composite key. We will be taking some examples later in the slides. When I say the key or the important parameter is partition key, it specifies how the data is stored or landed on the particular storage node. So this image I took from my book, System Design on AWS chapter 10. What DynamoDB, or like how DynamoDB works is, DynamoDB offers different kind of APIs. So users interact with those APIs. So let's say you specify some partition key Mandeep. Now what this request router component will do is, it will just take the hash of that key and then figure out where this data should be present, on what particular storage node this data should be present. And there are some auxiliary services, this is authentication system. I will have to figure out that if the user should be allowed to make that entry or not. There is partition metadata service. Let's say for my get query, I have to know that where this data is present. And there can be other services as well, such as admission control. Okay, let's say if this request should be throttled or it should be processed or not. Okay, so there are a lot of auxiliary services. This is a very high level picture of how it works under the hood. Okay, so now we know that how it works under the hood, I mean the high level picture of it. Now let's talk around what are the key things you should keep in mind when you are actually storing the data. Okay, so the first thing which you will have to do is, you have to figure out the access patterns. What do I mean from access patterns is, how your data is going to be stored, or how your data is going to be accessed, basically how your data is going to be retrieved. In DynamoDB or non-relational database in general, what you strive to do is, you store the data in a way that it could be retrieved easily. So that's the first thing you have to do. You have to figure out the access patterns, and if you can't figure out the access patterns, you might very well do not use DynamoDB. So this is a big statement, but if you are not able to figure out access patterns, you always have to ensure that you might reevaluate of using of DynamoDB. Okay, so this is much similar to any system you are working on. First you figure out system requirements, and then you proceed with the further things. So in case of DynamoDB, if you are using it as a storage technology, you figure out the access patterns. Once that is done, there is another recommendation which is given by AWS, or like anyone you see on the internet as well. There is single table design, and I will try to compare it with the relational databases. In relational databases, you have a database. In that database, you have multiple tables. Now in case of DynamoDB, what you can do is, or how you can compare these technologies is that the multiple tables here of the relational database can be treated here as DynamoDB table. Okay, and the different entities which are there. Let's take an example. Okay, let's say for a transaction object, I have transaction and then I have transaction history. So I have these two entities. So how will I do it in the relational databases? I will create two tables. But in case of DynamoDB, what you can do is, you can create two entities and they can both be stored at a single place. Okay, now I shared some theory with you. Okay, so how will you justify it? So I will try to take a opposite direction of it. Let's say I will use a multi-table design. So what could be some cons of that? So the first thing is client-side joins. Why client-side joins? Because in case of multiple tables, you will have to call those multiple tables. Remember that under the hood diagram, what you will do is, you are interacting with the HTTPS APIs to the DynamoDB server. So in this scenario, what you will have to do, you will have to call those multiple tables and then combine the data, because it's present at multiple places. This is the biggest con you have, and due to this reason, there is an increased latency and there is an increased RCU. RCU basically means how much read consumption units you are consuming for retrieving the data. So that's how you are charged. So there is an increased latency because you are pulling the data from two tables and then combining it in the application. And due to this, there is a minimum scope for query optimization as well. Why? Because you will always have to query those two tables. You can't optimize your queries. There can be minimal optimizations, but you can't optimize on a single table. So these are some of the cons, and this is the reason that we should prefer a single table. Why? Because there is a data locality. Data locality as in, you don't have to combine the data from multiple tables now. The data is locally present in a single table and then you can retrieve it. Second thing is less operational overhead. Now there is very minimal overhead when you are managing DynamoDB, but there will be such as, let's say, what is the RCU or what is the WCU which I have to configure. That's one thing. Okay, another thing could be that there are separate alarms which you have to monitor. And what could be the access pattern for that particular table. So there will be some operational overhead when it comes to a single table. And as compared to multiple tables, it will be much lesser, right? So these are some of the pros we should prefer single table. But the idea would be that you always evaluate, like whenever you are trying to design your system, you always evaluate that single table makes sense to me or probably two tables make sense to me. You always do that analysis, but we always try to ensure that we put in maximum number of entities in a single table. Okay, this is just a single simple diagram which shows that there are, like earlier in relational databases there were 3 entities, and that depending on those 3 entities you have 3 tables, and what you did was you combined all those entities into a single DynamoDB table. Cool. So till now we have figured out what are the access patterns is, I mean we understood what DynamoDB is and what are the access patterns or how we should do it. Now once you specified that these are my access patterns, I have said that okay, this is the way I want to retrieve the data. What comes after that? What comes after that is you have to figure out what will be your partition key and what will be your sort key. You will be coming up or designing your partition key and sort key depending on your access patterns. So there are some critical things we should focus on. First thing is high cardinality, which means that the data is highly unique. Remember from the under the hood slide, the data is stored in the DynamoDB storage nodes depending on the partition key which you have created. So if the partition key is not so unique, all the data will be landing on the same node, same storage node, which can create hot partitions at later point of time. So to avoid that at later point of time, we will be discussing some hotkey scenarios as well at later point. But to avoid that from the first place, you should always ensure that your key which you are designing is high cardinality. Second thing is, if you have done this, what it will do, it will spread the traffic across the partitions. That's what we are trying to do as well. And it will also help us to create multiple composite keys. So let's say you have defined a single partition key, and what you can do is, so let me compare it with the relational databases. If there are multiple access patterns, what you do is you create a single table, and then if you want to improve the queries further, then you create indexes. Okay. Now in case of DynamoDB, if you are creating indexes, it will add to the cost because it is much similar to the table which you have created. There is a separate kind of sub table which is created for the data. So what you can do is we can create composite keys, as in we will be taking some examples, but what you can do is you can combine partition key and sort key so that multiple access patterns are resolved and you get maximum out of it. Okay. So as I said, what is composite key? Composite key is combination of partition key and sort key. It basically specifies the relationship between different entities, and it helps in creating lesser number of GSIs because you are able to solve more queries with help of lesser number of data. And other critical thing is you are able to pre-compute the data. Why? Because you are storing the data in a way that it can be pre-computed easily, and the benefits of this is that you don't have to join the data. In case of non-relational database, we always want to avoid the joins because we will have to do that at application end, so you can avoid that. And finally, there is no application logic. You don't need any application logic for filtering. Cool. So this is one of the example. This example is again taken from my book. It shows how you can use a single partition key to support different query patterns. So here the partition key is property ID. So assume that you have a hotel system, and that hotel system is used to onboard different properties. Okay. So your partition key is property ID here, and depending on that partition key, you are solving different access patterns. So take a look at the first one. Your sort key is py, just a constant py. It will be used to get all the property details. The second one is, let's say I want to get all the images of it. So what you will do, you will specify the partition key as property key, and you will use sort key as py hash image. Okay, just start with this. And if you want to get details of a specific image, then you will specify the entire image ID. Okay, I hope that you are getting the picture of it. Cool. So if you see on this image, what's important here is that there is also some sort of hierarchy. When I say hierarchy, it means that let's say in a particular on a particular platform, let's say I'm using booking.com. On that platform there are multiple hotels. On a particular hotel there are multiple rooms. In a particular room there are, let's say, different room types. So there is some sort of hierarchy which is there. You can also use DynamoDB, or like you can store data in a way such that you can resolve those hierarchy key patterns as well. So let's take an example. You want to retrieve the hotels in a particular area. Okay, I'm visiting Chennai. I want to get hotels which are present in Chennai. So let's say to solve that, my partition key is country and my sort key is state hash city hash area. Okay, so my access pattern is, let's say, all hotels. So we'll enter the scan the entire table. I want to get all hotels in India. In that case, what I will do is I will use partition key as India. So I will get all the hotels which are present in India. If I just want to get hotels in Tamil Nadu, so what you will do, you will use partition key as India and you will use sort key as start with Tamil Nadu. So this way you are able to solve your maximum access patterns. So what I am trying to do here is, you didn't create any GSIs, you are able to reduce that RCUs. So this is what, when I say that you can do maximum with minimal cost. Okay, this is another example which is from like when I was at Amazon. So we used to use DynamoDB to figure out probable orphan shipments. Okay, when I say orphan shipment, it means that like on a particular sort center, if I'm not able to figure out where I have to send this shipment to. Okay, so this is how our access pattern looks like. We want to get all the shipments on a sort center in a particular time range, and time range is current time minus arrival time is less than 4 hours. Okay, so this is how our table was designed. Partition key was shipment ID and your sort key was sort center ID, and then we had a separate GSI with partition key as sort center ID. And how we used to retrieve the data, we used to query the data for this set sort center ID and then apply the filter expression once the data is retrieved into our application. Okay, so there was a big problem when COVID emerged. Why? Because none of the shipment was moving outward of the sort center. So there were a lot of shipments which were there. So if you see for that particular partition, there are a lot of shipments which I am getting in my application, and then I have to apply that filter expression. So our query logic was kind of choking. It was taking forever to resolve or figure out those probable orphan shipments. So this is how we improved the schema. Okay, we improved the schema by creating or like specifying epoch value in the sort key itself. Okay, so the access pattern here is that I want to get the range. Okay, so you can utilize your sort key to get the data in that range. So we introduce that GSI, and then after that what you do is you are removing that need of applying filter logic in the application. So it is automatically handled by DynamoDB. So this is how you able to, like, what I am trying to convey here is that depending on how you are designing your access patterns, they can very well evaluate on how well your application will perform. Okay, so we took some examples. Let's quickly go through what are some benefits of good design. You might have got the picture, but let's quickly discuss them. You are avoiding unnecessary GSIs, so you are saving the cost. You are also reducing the RCUs. Okay, so you are again saving the cost. You have improved query latency, so there are happy customers, and there is also minimal client logic for data filtering in the application because you are already doing that at DynamoDB end. So there are happy developers as well. So these are some of the good benefits, right? But the big benefit is that you are doing it maximum in reduced number of time. This is one important question, that can issues occur even after a good design? Let's say you ensured everything that I have my good design in place. So can issues still happen? There can, but what are those issues? So if we quickly talk about the capacity modes, there are two capacity modes in DynamoDB. One is provisioned capacity, and you can specify auto scaling and not, and there is an on-demand capacity. Okay, quickly describing what they are. Provisioned capacity, you have to specify what is the RCU, what is WCU for your tables. In case of on-demand, you don't have to specify anything. It is a completely serverless. It is managed by DynamoDB entirely. Now, when to use which? If you know that what will be your RCU and WCU, then you can use provisioned. You can use on demand if there is unpredictable traffic, as in you don't know what your RCU or WCU is. Okay, so I'm assuming like you might get this idea in your mind that if I'm using on demand capacity, okay, or if I'm using auto scaling, then there will be no issues, not throttling will occur. DynamoDB will not throttle your request. But that can still happen. That can still happen if there is a hotkey scenario. Hotkey as in if the single partition is breaching the limits. DynamoDB enforces some limits at a partition level. Okay. When I say partition level, if you are breaching, let's say, limit of 1000 WCU or 3000 RCU, your limits will be breached. If your auto scaling will also take time to kick in. Okay, let's say you have specified your percentage utilization as 60%. So after 60-second percent is utilized, then it will try to scale up. So that will take time. But in case of spiky traffic, the effect that it comes in picture can be more. And similarly, in case of on-demand capacity, there is some base level which is allowed for a customer, then it is doubled in case throttling occurs or when the capacity is utilized. So we'll always have to figure out, always have to say that yeah, these are my limits, and depending on these limits I do best. So these are some of the things which you can do to avoid throttling. First is you resolve the hotkeys. How you can do is we will be discussing that, but the first idea is that you create those partition keys in a particular way. You can configure the target utilization to a lower value. So instead of, let's say, 90%, you can say it 50%, and you can do pre-warming in case of on-demand. Let's say you are expecting spiky workloads. So you can test your system against that spiky workload beforehand, so that your already that capacity is in place. Okay. So one thing was, one issue was that there can hotkeys can occur. So how you can handle it? First thing is, like, whenever a problem occurs, what you do is you figure out or you troubleshoot those issues. There are two ways which you can do is, one is that you can use managed service, which is metrics which are offered by CloudWatch. Other thing is you have some logs or custom metrics in place at your application. Cool. So these are two things. You will first have to troubleshoot that this is my issue, and once troubleshooting is done, then you actually implement those solutions. Okay. So these are some of the solutions. First thing is you use high cardinality keys. This is again, like, always important in case of DynamoDB, that you specify high cardinality partition keys. Now let's say you already designed your system and this problem is occurring, and what can you do in that scenario? Okay. So if that scenario occurs, there are two things which are recommended. First thing is you try to cache. You try to, okay, I will try to wrap up in 2 minutes or so. My time is over, but let's quickly close it. Okay. So you can try to cache the system. When I say cache the system, cache the queries if same pattern is occurring again. Okay. This is true for any application or any queries which you do. I will try to cache it. Either you cache it in your application or you utilize some of the solutions such as DAX or Elastic Cache. Third thing is sharding on writes. What you can do is, whenever you are creating those partition keys, what you can do is you can append some prefix or suffixes so that your data or your partition keys are differentiated. Okay. Another misconception with the DynamoDB is that there is an infinite scaling in place. Okay. When I say there is zero operational overhead, you can store any amount of data, it is fully serverless and all those things. DynamoDB also enforces some kind of limits on the storage. Again, on a single partition limit, there is a 10 GB of only storage which is allowed. Okay, this is on the storage front, and for the particular entity, you can only store maximum 400 KB. Okay, and same on the request throughput. As I earlier discussed, in case of throttling, like when throttling can occur for a single partition, whenever you are querying a single partition, there is a limits which are enforced, and these are hard limits. Okay, these are hard limits which you can't change basically. So the picture of infinite scaling can be wrong. Another important question here is, if I say that, so these days I mean Amazon DynamoDB also offers transactional support. Okay, so you might get this one question in your mind, that if DynamoDB is doing everything, like it offers horizontal scaling, it offers transactional support, do I even have to consider using relational databases? Okay, and this is important as in that if DynamoDB can solve everything, do I have to even check on or spend time on comparing these different database technologies? So the answer would be that you will always have to compare the technologies, because transaction is not the only support which is offered by the relational databases. Okay, let's say you have ad hoc queries, you don't know what your access patterns are. So relational database or any database per se shines for a particular use case. You should always evaluate on what makes sense for you. Okay. So we will quickly close up on some of the best practices which you can follow. First thing is you should always project needed attributes on the GSI. So whenever you are creating an index on GSI, always figure out what are the attributes you need and project only those. Try to create composite keys as long as possible because you will be saving the cost, and this is true for GSI as well as the tables which you create. Avoid scan because you will be consuming more RCUs and also increasing the latency. Delete older GSIs to avoid your costs. On the querying front, always keep track of metrics alerts, whatever metrics, throttling and all, you have to figure out that. And finally, depending on like what data you are querying, apply those key condition expressions and filter expressions wherever needed so that you can make best of it. Okay. The final slide is don't use DynamoDB for. I am quickly closing this up. Okay. So don't think it as a replacement of relational databases. If you don't have clear access patterns, skip it. If you have complex ad hoc queries, don't use DynamoDB. If you have GSIs, let's say you want strong consistency across the entities, across the indexes, then DynamoDB might not be a good choice for you. Because you need horizontal scalability, then you can skip it, or to sound cool, just to say that I am using a serverless technology, don't use DynamoDB. Okay. So this is all which I wanted to cover today. We don't have time for Q&A, so you can always connect with me after the session. And yeah, thanks everyone. Speaker is this one.
Here?
Our next speaker is an entrepreneur and cloud expert, passionate about cloud automation and accelerating startups. As the founder and CEO of Cloud Engine Labs, he has been driving innovation and helping organizations harness the power of the cloud to scale. In this session, he'll show us how AI and serverless come together to deliver secure, scalable, and production-ready solutions. Please welcome Mr. Saravana Nyanaguru.
Can you move it a bit this side?
Okay, yes.
Why not left? It will come. Column icon. Is this fine?
Yeah, this is.
May I plug this column icon?
Okay, sure.
Thank you. It's done.
Thank you.
Can I start? Hand mic or? Okay, sure. How are you, everyone? Yeah. Okay. So, actually, I'm kind of cutting you all in almost lunchtime. So, bear me for 20 minutes. I'll make your time useful. Okay. So, yeah. Let me start my presentation. So, yeah. So today I'm going to talk about, or I'll be kind of equipping you with setting up your own private GPTs using AWS Bedrock and AWS Lambda. Okay. So let me start. So this is about me, myself Saravanan, and I am founder and chief technology evangelist of Cloud Engine Labs. So we are providing technology consulting solutions to client on various areas of cloud DevOps adoption, and we are also developing our own products with respect to DevOps adoption and cloud. And we are also recently started developing our own GenAI products as well. And I am being in the community, I am contributing to community for more than 7-8 years, and I am part of AWS Community Builder program and HashiCorp Ambassador program as well. So this is my website. I have all my social links mentioned there. Okay. So if anyone wants to connect with me, you can connect with me, and I will also be here after the session. So like, I just want to ask you guys a question like, no, what is the need for setting up a private GPT-like system? Anyone can answer, please, quickly. Why do we need a system like a private GPT? Sorry? Yeah, correct. Anyone else? Yeah. So yeah, so basically that is about it, right? So basically, like, industry is moving towards setting up, like moving away from internet-based LLM and GenAI systems, and every enterprise organizations moving towards setting up their own GPT-like system in their own infrastructure, be it AWS or any on-prem system. They are all moving, right? And for internal teams, we cannot access provide our document to the internet-based systems, right? Because they are kind of using our own data and training their own models, right? But with respect to proprietary information, it is always a risk to push this data into the internet. So that is also another reason every organization is moving towards a private GPT-like system, right? So when I say GPT-like system, it's one of the famous system that is in place. That's the reason I took it as an example. So and third one is so data exposure is very critical, right? So currently everybody is developing GenAI products using vibe coding and everything, but they are all using internet-based systems. And if at all, if they wanted to make this products live, the problem is that they are there is a chance that they might expose users' personal identifiable information, right? So this is the very much of a hot topic currently in industry right now. So if anyone wanted to explore in that way of setting up private GPT-like system, that is a very good scope of work will be there, and you will get very good amount of job or anything will be there, because this is just starting. That is the reason I am kind of giving you guys an idea of how to do it through AWS systems, right? Let me move on. So why choose AWS Bedrock over open, freely available model hosting, right? Because there are model hosting mechanisms like LangChain and everything is available. But why we need to go for a system like AWS Bedrock? Because AWS is a kind of one of the hyperscaler currently available in the market, and they are the industry leaders for a long time. So it is good to go with the system like AWS, so that you can have a VPC setup, private network, on-prem system, everything you can do it through AWS, right? So the first thing is if at all, if you wanted to host and take a model from internet and train it, so basically what we have to do is we need to buy a infrastructure for that, right? So it is actually very high cost. But AWS is providing a managed services, and it is having a lots of model already hosted in their model catalog. So we can use those model catalog, and we can pay for the usage pricing only, right? So we can tremendously reduce the cost, and with the benefit of privacy as well, right? And the second one is AWS Bedrock supports many models like Claude and AWS's own proprietary models, and whatever you name it, Gwen, everything is there, right? So basically, like we have a choice of choosing our own model based on our use cases. And fourth one is like unified API access. So AWS Bedrock provide multiple API methodology. The major two classification is Converse API and Invoke API, right? So through Converse API SDK, you can access the systems like Claude and any similar conversational models through Converse API SDK, and Invoke API is basically for the one-to-one interaction, training models, embeddings, and those kind of things. We can use Invoke API. And next one is like production ready scalable platform, because since we are using Lambda as a background for running the Python code and everything, right? It is actually easily scalable, and for Lambda serverless also we will be providing only the usage based pricing only. So, and fifth one is like privacy focused with no exposure to the internal systems. So this is the key pointers we wanted to go for a system like AWS Bedrock rather than open source LLM model, LLM deployments. And for the purpose of today's architecture, this is what I have prepared. Like first one is I will be showing how the AWS setup is being done, and the second one is how the dedicated VPC deployment is done. And we have used a model interface using Bedrock API, the Converse API SDK I told. And the fourth one is we are also using S3 for the provision of storing the memory for the chat conversations. And I have built up a Streamlit UI for a chatbot interface, and that interacts with the backend Lambda system that is runs on the AWS Bedrock. Okay. So this is the high-level architecture you can see. So in this high-level architecture, you can see this is user will be providing chat messages through the Streamlit web UI. So here I have mentioned Streamlit because this is a demo purpose. You can wrap it around with any kind of UI tool, you name it, React or Next or whatever it is. You can wrap it around that, and that UI will be interacting with Amazon API Gateway. Okay, and that is in the public subnet, because that is the first level of security we are providing. And this blue box is the VPC wherein we are deploying our AWS Bedrock, and that is completely private system, right? So you can see we can configure our environment, and based on that configuration, you can see this is completely isolated from the internet. So it has to go through so many levels of interaction to reach this level of LLM model, right? So this is the key focus of today's session I wanted to highlight. This is the reason we wanted to go to system like AWS Bedrock or hyperscaler like AWS to implement your own private GPT system, right? So because enterprises are moving towards, you name it, fintech companies or all the larger enterprises like this. So if at all as a student, if you wanted to explore that career path, you can just learn about it, and I will also be there. You can reach out to me, and then and for care. And as I mentioned, like, we will have to monitor the request coming having, even though it may seem negligible for a volume of requests coming in or going out, right? You will be charged high, right? So for that only we will have to set up dashboard and everything for from the interface I showed already. Okay. So yeah, so let me jump on to the demo quickly. Okay, so yeah. So this is the architecture diagram I have showed you already, right? So we will be having an Streamlit TooIs interface through which that chatbot will be interacting, and it will be sending the request to the API gateway, because for all the Lambda requests it will be wrapping around with the API gateway, and then the interaction will be going to the backend Lambda code through which that endpoint's been exposed, right? So that is what it is. And for this demo, what I have done was I have prepared a complete full automation, AWS automation using Terraform, right? So I have spinned up already because of the time constraint. It will run for another 20 minutes, right, for the infrastructure creation itself. So what I have done was I have already prepared everything, and I have quickly show you what I have done, right? So this is the AWS Bedrock Terraform code I have prepared. So whatever the infrastructure elements you are seeing in this architecture diagram, you will be seeing that component is being created through Terraform, right? So you can see here, this is the Lambda code we are talking about. So this is called Lambda handler, and in this Lambda handler only there are various functions available for doing the chat interaction with the chatbot. I am using Claude here, right? And so you can see first it will do the change the chunks of messages into text blocks, and then it will pass it on to the backend Lambda code. So I don't want to go through the entire code because it might be very high level. I feel so. Next one is I have structured entire my infrastructure in Terraform using modules, because that is one of the best practice way to implement Terraform IAC, right? And then this is the main.tf file wherein I am calling all the infrastructure components that I have defined as a module there. Okay, and as a so moving forward, how to execute this demo, right? The first step is spin up the environment using Terraform code. Okay, so I have already spinned up the environment and it's already been up and running, right? And next thing is once after the environment is being spinned up, there are authentication mechanism we need to integrate with the UI. For that I have used Cognito API, okay, Cognito methodology, wherein that is also another service from AWS. So using Cognito, we will have to use a Cognito pool ID for configuring a username and password. So that also I have set it up. So first one is setting up an infrastructure creation. Next one is creating a user in Cognito, and third one is running the Streamlit application, right? So I have already run it. Okay, I will just check. Yeah, I'll just check the internet connection so that. Yeah, internet connection is there. So yeah. So this is the login screen. So as I mentioned, this is the private GPT I am talking about. Okay. So if you are setting up for an like an enterprise, this is how it should be done. Okay. My username is test@example.com and password is okay. I'm logging in now. So for this login only, I was talking about creating a Cognito username and password, so that the entire API request will be authenticated through that methodology. Okay. So this is as I mentioned, this is a simple chatbot I have created, and I have enabled only one model for myself. Okay. I will also show that at the end of the demo. So basically this is like a system you can consider. You can add n number of models here. I have added only one model here, and you can choose based on your own request. And if at all, if someone is developing an app for like an LLM model wrapper, this is also one of the use case, right? This is how you have to do. So you can enable the models, and user should be able to choose the models from the selection box, and then they can run it, right? So I'll just type a message here. So I'll be sending the request. So this Streamlit code is already in configured with all the required values for the Bedrock connection. It may take some time because I haven't tuned anything on the quick response, right? And I don't know about the internet connection as well. So yeah, so now that request is going, and Claude in the background running that, okay, and it is bringing up the response, and it is showing the UI, okay. So I have asked for it, what is the AWS student community day, and it has provided a response. And yeah, and if at all you want to have it as a conversations history, something similar like a GPT like system, right? So that is what I have prepared, okay. And yeah, and I am almost completed my demo, and anyway I will be here around today, okay. So anyone wanted to catch up on this, I am happy to discuss, right? So yeah, thank you. If at all, if you have any questions, you can ask me. Otherwise, I can wrap up the session. Any questions? Okay, thank you guys. Thank you for being an awesome audience. So this is actually we are doing for one of the client. Actually, this use case is being inspired from the client's use case, right? It's a real scenario, I would say. Yeah.
One question, sorry.
Yes, yes.
Before you even ask,
No problem.
I was expecting someone.
No problem. Yeah.
This question is like, since you're making it as a private one, right?
Yeah.
So what about the knowledge base? Like, since you are interacting with this now, since you have fed this knowledge, so
Correct.
there has to be a point of time where you have to do a batch processing of inputting the data at certain or synchronizing
Yes, correct.
the real world.
Yes, correct. So in the real world, what you have to do is there are document models and those kind of things are available, right? So in Bedrock, what happens is, so when you create them inside the VPC, it becomes as a private for your own organization only. So you can, this is just a conversational model I have, demo I had, but we can also do it for document model, whatever you name it, image models and whatever models are available in Bedrock, you can do. Yeah. Okay. Correct.
Thank you so much, sir. Thank you so much, sir, for that insightful session. So now we request all the industry participants and speakers to move towards the first floor. We have volunteers, they will be guiding you. We need you to move to the first floor for group photo session. We request all the students to please stay back, and we'll be taking you for lunch soon. Clear? You can actually go and see the stalls that we have put up outside. Thank you. Thank you, sir. Sir, thank you.
Yes.
Thank you so much, sir.
மைக்க மட்டும் கொடுக்குற டப்பா எங்கடா வச்சிரும் ஒன்று பிரணவ் பாக்ஸ் மார்க்கு
what we do it for just one game is like where alphabets fall down and we have to.
We'll check.
Sure. But the thing is like he had some work, so
I just need a pause because like I'll talk to you after the session. Sorry to Is it working?
Yeah, it's okay.
Projector.
Projector.
Okay. No problem. That's okay. Guys, hi, I'm Padmini Subramanian. So the projector, they're just fixing it. So you know that our session is building careers in SRE and performance engineering practices. So it's all about building career discussion. So we'll keep it interactive and discussion. So I request you to, come closer, like have a closed space because let's have it as a discussion. Is anyone not comfortable when I talk in Tamil? Like, are you all comfortable if I talk in Tamil? Like, does anyone doesn't know Tamil or? I won't be taking the full session in it, but then and there if I pause. Guys, கொஞ்சம் முன்னாடி வர முடியுமா? Like in the space, let's cover. Let's keep it interactive. Okay? So the agenda is like, we're going to see like how you can build your careers in SRE, and there's also this performance engineering practices in the industry. So how you can prep up for that. Okay. So how many of you are like AI domain? Okay, what is your engineering domain? Like mostly? All are from AI, yeah? Let's keep it interactive, no? Tamil கூட பேசலாம். எல்லாரும் வேற வேற டொமைன்ல இருந்து வந்திருக்கீங்களா? Oh, okay. Computer science and AI, AIML, IT. Oh, IT irka? Oh, nice. Okay. IT, Chalet IT. Okay, I forgot. I'm sorry. Okay. So, okay. Yeah, what do we do? It's ready? No, that's okay. Yeah, I'll just give an introduction about myself. I'm Padmini Subramanian. I work for JPMC as a performance engineer. I'm an AVP, and I take care of SRE practices as well. And I have upskilled more than 1,000 folks in like making them certified in my organization. I was a community builder until last year consecutively for 3 years, and I'm studying AIML with Great Lakes and University of Texas in part-time. So I just backed off from most of the AWS events this year, and I was part of their Women in Tech initiative as well for a short stunt, but that's what I think. Even I have to upskill myself, otherwise I know I'll be kicked out. And I'm also working with, just started my profile as an AIML performance engineer in my firm. So this is about myself. And I was a global mentor with TopMate, like some of the students I know here, like Vishal, Rahul, and all, like Abhi, you know, like are my mentees as well. So yeah. So this is about myself. I wanted you guys, like mostly you'll be focusing that you wanted to become an AIML engineer, right? Or you wanted to have a computing science background, like computer science engineer. There are a lot of opportunities now. Like what I was just telling to your buddies was that for the AIML foundations, like how physics and mathematics So people have started moving towards the quantum, robotics, and then automated cars, these stuffs. So I had a realization that if I am not mathematically trained, I don't know, I didn't have much confidence on, to an extent, yeah, I believe like LLMs and all would help, but if I'm a graduate from MS software engineer from VIT Vellore, so like having this similar to yours exposure, like what I stepped out as an engineer from similar sort of reputed institution, I felt that after a decade, if I don't, our field is like that, like if we don't update ourselves, and as they say, AI bubble, like, right, like, I might also in future like that. So we are upskilling, it's a necessity that we have to upskill ourselves and chime into the next level of technology. Like, okay, that thing. So coming back to our performance engineering stuff, right? So you would have a vision currently, like if you're stepping out today, you would be checking for AI ML engineer. But actually in the industry, what we are doing is from a tech aspect, from a technology service aspect. I build applications, I evaluate the performance of application with respect to investment bank. So of course JPMC, like we have multiple line of business. So I work for investment banking applications. So why am I telling that? It's like I evaluate performance. So it's not just about the development. There are a lot of other scopes as well, where you can look into that sort of profiles, apply for them, and one such interesting profile is this performance engineering or SRE. You would have been taking this DevOps certifications, right? So not everyone will land in the same DevOps profile, but still there are market availability that you have opportunities with this sort of SRE, site reliability engineering, and where you take care of the reliability aspect of the application. And there is also non-functional testing aspects or non-functional engineering aspects, like Chaos engineering is there, where AWS has FIS, fault injection service. So these are all like categories where you can build the profiles when again this performance engineering. So this comes under the non-functional aspect. It means like development teams are there, testing teams are there, and then once your application is live, you have, if it breaks in the production, means like in the live, so to fix that, you have production management or incident management teams. So these incident management teams or people who handles, who's there? Okay, great. Yeah, I'll take a pause. So that's what. So this sort of incident management, and then if your application is slow, to tune that, to make it faster. If a car is driving slow, would you like it? You want to ride it fast. Similarly, when you access any application, when you make a transfer, your parents are making a money transfer to your account. If it goes by NEFT, like the old traditional process, would you be happy? No, you need the money at the next moment. You need to see the text. So your application has to be faster. So that's where this sort of performance engineering profiles comes into the picture. And let's see in detail about it. We have our presentation ready. This is my LinkedIn profile. So if you'd like to connect, you can give it a shot. And one thing I would like to announce is like at the end of the session, so if you could, if the first two who comes to the stage to give a narration, like what you took away from the session, what was endorsed and what you took away. So you would get I got two author-signed copies of a good non-fiction book. So one is a biography, another one is about tech. So I would love to gift it. And if you could write a blog post if this session was useful in LinkedIn and tag me, I would like to send you a book. So I'll just give a minute to connect. Fine? Okay? I guess it's okay, isn't it? Can I move to the next slide? Is it okay? Can I move to the next slide? I just wanted to start with a quick story. Okay. So, back in 2014, there is this famous e-commerce site, which there's this famous e-commerce site which we daily use, Indian e-commerce site. So I can't give the name. Okay, let's start with that. Okay. So this e-commerce site, they announced the big billion days for the first time, and they crashed, and they had to send some money to the people who placed an order, and this is not just they repaying the money, but it also matters their reputation. Think of you yourself as a CEO. You're selling something, people are booked, but they're not receiving the product. Reputation, bad name, right? So this is where the performance comes into the picture. I expect 1,000 users to a system, but people are so attracted to the sale, they end up using, 10K people landed up to the application, and it's crashing crazily. So that is a matter of reputation. That's where this reliability, scalability, capacity, and performance, these all comes into the picture. So So when we talk about this sort of issues, failures, what does SRE do here? So you're gonna use some concepts, like SRE was introduced by Google back in 2014. Like, you know that how crazy people use Google. So, and it's also faster, quicker. So in that case, they were the first one to come up with some golden rules that this traffic, errors, latency, toil in the sense like you see a continuous incidents, crashing, same sort of patterns. So how you can put a fix and automate it so that like in future you don't see it. So this sort of concepts, and mainly before the site reliability engineering observability concepts, it was just monitoring. Means like you were just monitoring the Java virtual machines, CPU memory in a monolithic or three-tier architecture that way. So three-tier is nothing but the whatever request you're hitting means like I search for google.com or an abcbank.com. So I hit it and it goes to the UI, like the look and feel, web layer, and then where it hits the application logic. So if it is a calculator application, all your plus minus, these things goes in the logic and then the database layer. So you see this sort of application initially, early days, it was just a monitoring. Now we have moved to a concept of observability. That we'll see later. When we talk about observability, they use these terms SLA, SLO, and SLI. So SLI are, what is my concern? My page has to be responsive. My page has to load fast. So a responsiveness is an indicator. And then whether it's fast or slow, it gives some indication, right? So these are the SLIs. And then objective, SLOs are the objective. And then in the sense like I can have 1,000 users at the same time accessing my application, that it should load in 8 seconds. So, but suppose if 10,000 users loads instead of 1,000 users, what would be my response? I have to measure that also. So these are all the objectives. And then agreements, SLAs. So SLAs are like you talk to the business. Directly tech won't talk to the bank managers. There'll be a mediators to communicate. They're all products and the business people who translates into the architectures and all. Like we talk to the products, not to the clients. So this SLA, SLO, and SLI are part of these SRE's observability. And that's what. So first concept is monitoring. You have tools like Prometheus, Dynatrace, Splunk on different categories, which we're going to see in the observability. And you will also be identifying what incidents happen in the go live. It's like I was telling, instead of 1,000 users, 10,000 people ended up, it crashed. Your development teams and production incident teams, testing teams, all sit together and put it back to the BAU. BAU is business as usual. So how are you going to handle the incident? You'll be setting up the same observability dashboards to find where the issue has happened. What has caused I can say like 10,000 users crashed it, but which code has cracked? So on this observability, there are these 3 categories, logs, metrics, and traces. So I hit an application, I get the page. So these all comes under 2xx, means like 200 response code. I hit an application, some code has crashed it, so it will be in the 500 response code, 5xx. And then I have given a wrong username password. So this will be like client side issues. So it will be like 4xx series of response codes. So these all comes under the same monitoring, okay? And also the incident response, like you set up the monitoring dashboards, fix the incidents, so you leverage those tools. And then capacity planning. So with X number of core CPUs, I'm able to handle so much volume of users. But if I expect X plus N, how much cores I need? So that sort of capacity planning is also important. Yes. So coming to the like you guys are like computing science background and AI background, so that goes as a core. Means like you must be having operating systems book, right? That is the fundamental foundations. So whenever you run an application, you'll be saying like, you also have to, means you guys will be doing your projects, right? So usually you'll do a functional testing, unit testing, integration testing, and then you host the application live. But there is also a non-functional aspect. So when you are evaluating, submitting this project to your interviews or to some other IT professional, if you could incorporate this observability, or else if you're trading your resume, not just the development stack or along with your development stack, if you just mention this observability, like you're measuring the SLA, SLO, SLI, and then you're using this incident response or monitoring by handling this Prometheus, means using this Prometheus for that 2xx, like 200, 500, 400 response codes, whatever I told. And then if you're using, like you're running a Java application and you're using Splunk to go through the input and the output logs. So I gave a wrong password, so it's popping up some error failure message. So this sort of logging, see Splunk and the Dynatrace are, I started my career 12 years ago. Splunk is a very niche tool. So you must be certified in AWS. Along with that, if you have certifications like Splunk and the Dynatrace, I'm sure like definitely it's gonna create an impact. So these are all insiders. I mean, like we in the tech, we leverage it day to day. So I recommend you for the certifications. You need not complete. See, you are college graduates. These DevOps professionals who has really like at least 3 to 4 years of experience. This is my opinion. Are doing it okay. But at least if you can complete developer associate and associate level, it will give a good impact. And all these tools like whatever we discussed, the Prometheus, Amazon, for AWS we have AMP, Amazon Managed Prometheus. And then for in the SRE practice, we'll be seeing one thing called Kaios engineering. So Kaios is like you're going to introduce, that's also a domain in the SRE, where like you're going to test some experiments, like you'll be introducing a high target for breaking the CPU and create an incident, and then you're going to work on mean time to recover, MTTR. So this sort of experiments is there in the AWS FIS, fault injector service. So in mine, like in my firm, like we use a hybrid model, like both, this one, private and the AWS together. So on a hybrid cloud. So in that case, like we have our in-house tools, but we are also experimenting FIS in it. So in your profile, in the SRE, along with your developer associate certification, of course you would have learned about this CI/CD, like this sort of continuous integration in continuous deployments. Like you do the leverage the Jenkins, and there are also many AWS tools like code pipelines, code commit, these things, code deploy, n number of tools in AWS. So in the SRE profile, it's important that you also incorporate this sort of tools. Always have a blend of one public cloud, of course the ace in the market is AWS, and open source. Give priority for both. Like if you are an AWS associate, developer associate, you can also do CCAD, Kubernetes Application Developer, by the Linux Foundation. So that one, that certification has hands-on programs, like 17 to 22 programs will be, you have to code in 2 to 3 hours. That also has an industry value because you're not going with an MCQ. You're going to program, and it has a one tab open option, like where you can go as an open book. You execute the program, so, and then they certify you. It's not an easy exam, but if you leverage Udemy's courses, so will take enough hands-on, you can also crack that certification. That also has a good industry value. So again, Prometheus also, by the same Linux Foundation. Even I took my certification last year. So Prometheus certification is also there by this Linux Foundation on open source category. That certification also has its value. So, and Dynatrace for tracing means like you are running a Java program, you have 5 functions running. Which function has taken much time to execute, and you can put an optimize, you identify a bottleneck. In terms of performance issues, we call it as bottleneck, and you can put a fix for it using this Dynatrace. Dynatrace associate is also there. So when you have an AWS certification, associate level, and don't stop with the foundation level, go for the associate level. And you need not, you are college graduates, like if you are comfortable, go for the professional level. But during the interviews, like when you're going to trade your profile in the right way in the interviews, it's better you stick on to the intermediate level, where like associate is an intermediate level, and also have some open source certifications in hand, or else this sort of Dynatrace and Splunk certifications. People doesn't endorse much about these Splunk or the Dynatrace certifications, but trust me, it has helped me to trade my profile for a long time, and because these are NIST certifications, so people trade good in the industry. So I recommend that also for you, like you can, it's not just about the certification, you must be, and these certifications you don't see much materials around, you have to take the manual, and Udemy or those courses are there. Like, ensure like you have the good hands-on, and also when you apply, like you're going to customize your profile. So when you incorporate the Splunk or the Dynatrace or Prometheus certification, put a real case. So and it matches the requirement, and also a use case, like where, hey, I was able to see the metrics where I learned these things in my Prometheus certification or Dynatrace certification or Splunk certification, and that's how you can, that's how I built my profile. So that's it. And tools, I discussed enough. In the industry, like we also use this Terraform. Like you have auto scaling option in AWS, right? Like, for the infrastructure as a code. Similarly, you have Terraform also. Terraform also has its certifications. So that's also good to have. Oh, I'm going back. I'm sorry. So I spoke about chaos engineering, the FIS and MTTR. So again, like when I go back to the performance engineering, right? So like I told about, I expect a load, but I ended up in X+1 or X+n. So would it work there? What would be my expected workload? Would be my target, and with that workload, what would be the responsiveness of my system? And I want to have it as a immediate, or industry standard is like a user as a patient to wait for 8 seconds. So how fast it is. So how I do it is, we have some tools like this. So we have tools like JMeter and BlazeMeter. So this thing happens, like we have a lot of non-prod environments before we putting it in the production. We have dev environment, we have test environment, and then we have performance environment and UAT, user acceptance testing, and then the code goes to production. So when I say like perf environment, you know that developers will develop in the dev environment, and the testers, functional testers will do an integration testing or functionality testing in the test environment. And these all will be like improper scaled or low provision as such. But curve will be at least like to have half of the sizing and the scaling. Sizing and the scaling. When in my case, like most of the projects I work, it's equally scaled. Scaled in the sense, sized and scaled in the sense, the number of core CPUs, memory, so these things. The number of instances, the number of pods they are running should be same like production. Why? Because I would evaluate whether my application, I would be bombarding load. My product comes and says like, okay, next month we are going to have 10,000 people new to the application. Would it scale? Would it support? So I'm going to mimic that 10,000 user load in my application. So for that, I need to have a prod-like environment. How I do it, I use these open source tools called JMeter. So JMeter, you can build scripts. This is Java based, and you can build scripts with that. And all your your application would have been hosted on microservices. But as an end user, like you would be doing some scripting activity. Like if you are familiar with Selenium kind of tools, this is also similar. So you would build scripts, and all this, since this is an open source for more than 2 decades or something, like all these resources are there in the normal YouTube only, like you can surf and get it, or in Udemy. So you run these, you build the script and mimic that 10,000 users and evaluate like how fast your application is. So since it is open source, if I have to bombard 1 lakh users for a billion sale or something, I would not have enough provisioning if I ran it from my local machine. So I leverage BlazeMeter. BlazeMeter also has BlazeMeter University. If you just want to show yourself like you're a continuous learner and put some small certifications, so you have BlazeMeter certification in place. Again, like there are different small certifications with them as well, and it's free. So to showcase yourself as a performance test engineer, you can use just testing purpose. You can use these BlazeMeter certifications also. Just that, like the local JMeter scripts you'll be uploading in the BlazeMeter, and it can create triggering the test executions from multiple global presence. And it collates from all those global presence and put in the, you can see a live monitoring report of your, like what is the response time, and then whether your application is sustaining or not. If it's breaking, whether it's breaking at the client side or the server side, 4xx error or 5xx error, so those things. And most of our organizations use both JMeter and the BlazeMeter. And I was mentioning about the Dynatrace and the Splunk. So what they do is like, both these Splunk and the Dynatrace, they're all agents, some agentic softwares. They install in your microservices. So what it does is, it captures the CPU and the memory, all this resource utilization stats, even the Prometheus also. Just that the Prometheus is like, the way it performs, the model is slightly different, architecture model. They say that has the push technology. So these are all like our vendors, like all our applications are client for them. So they have this customized agent, because Prometheus is like open source. So these are all maintained by companies. So they install the agent, Splunk as forwarder. So, and what it does is, Splunk will collect the logs, your web access logs, they say. Means like, if you server logs. At this point of time, you have logged into the application. Similarly, 10 others have logged into the application, and this is their credentials. Out of 10, one person has given a wrong input and output, so that he was not able to log into the application. And then other 9 were able to log into the application, and they were able to do the transactions. So your web access logs are all captured. Okay. So this all will be able to analyze the bottlenecks or issues. Initially when we started with the SRE, we were talking about the incidents. So to analyze the incidents, you have these sort of things. And then for the Dynatrace, the traces means like you have these programs running, which program or the function has taken or degraded or has a bottleneck. So those things you will be able to capture and identify. So it takes the trace. It's like I have run a calculator program. It has executed plus minus. Plus has broken because some heap has crashed. So the heap was set for 256 MB. It crashed for 100 users. So these are all the examples that you will be able to identify using the Dynatrace. So logs, metrics, and traces. For logs, Prometheus is there. AWS has AMP, Amazon managed Prometheus, and the open source Prometheus, you have a wonderful certification from the Linux Foundation. You yourself can explore. Why I'm reinforcing this is because when you're building your final year projects, incorporate these on an observability stack. Logs, traces, and metrics, SLA, SLO, SLIs, and this. Prometheus, Splunk, and Dynatrace. Prometheus for metrics, Splunk for logging, logs, log analysis, and then Dynatrace for traces, server traces. So with that I conclude. If you have any Q&A, then we can discuss. Yeah. And I would like to get questions from students on priority. And I would also call out two students, like if you could come give a narration, at least on the tools, whatever we discussed, I would like to give you a book. Yeah, come please. Happy. You begin? Yeah, just 1 minute, I'll be happy. What's your name? Roshan, okay? We have Roshan here. So you give a just 1 minute of. Okay, you can give like at least 5 sentences. Or name 3 tools or 5 sentences.
It was really very helpful for me because I'm also working for, like in my engineering project, I was really helpful for this, and mainly I was using that like in we are also AWS tools, and like I have never heard about that, like Prometheus and Dynatrace and Splunks. So like it may be helpful for my final year project and everything. Like I can ensure that like if it makes like in like in that I could able to like I can getting to know, like currently I'm studying 3rd year right now, but I never heard like these kind of words and these kind of tools are here or not. I didn't know anything about that, but this is a platform to know about. Then this is really helpful for me, and that's it.
I'm happy about that. Thank you, Roshan. Great, I would like to take a look. Great, Roshan. You want biography or you want about tech? This is like you want how you work technology. Yeah, this is an you want to begin? Can submit? Yeah, talk. So I really appreciate this. Thank you so much. I'm really happy that it resonated well. Looking forward that you implement any of these tools and it helps you in growing your career. This is by Deepa Malik. It's an author-signed copy, and I had an opportunity to meet her recently. So I would like to give this to one of my mentees. So today, like I'm really happy that you were able to deliver this. And Deepa Malik is a Paralympic champion. She won many gold medals for India. So I wish like all our positive vibes go to her, go to you as well. Good luck in your future. Thank you, Roshan. would anyone else come? Like I have another autosigned copy. That is by Megha Gupta. Again, I met her. Yeah, this is a uncoded technological history of independent India. So yeah, can I give an opportunity for a woman? but I will send you a book, okay? Come. Hi.
Yeah guys, good afternoon. So myself Divya Murgesh from Chennai Institute of Technology. So as we ma'am said in the session, as you guys, Tamil ellarku puriyundane.
Yeah.
So yes, I just completed my associate level of certifications, and just doing that, it is not to stop studying and doing such things. So after doing a certification, we have to learn more tools and integrate more tools to our final year projects. I come to know from ma'am that I'm really very new to these tools like dinosaurs and then J meters and blaze meters. So it's actually really thankful ma'am to you to introduce. This is really a very good session for me. And as I have completed my certification, I was not continuing my process, and this makes me initiate to the next step. I think so. All the best for you guys. Thank you.
I would recommend you to write a LinkedIn post and tag me. So yeah, if you do it, like I would DM, I'll get your address, I'm sending you a book, okay? I'll be happy. Hope this session helped you well. And if possible, if you could come here, we can click a picture together. Whoever would like to. I will be putting in the social media if you getting your consent here, so we can get a picture together. One set can stand down, one set can. Yeah. Stop, no? Okay. Please come. Please come. You can come. Please join us. No? Please, if you're comfortable, please join us. So, please, if you can come. No, if you're comfortable, please come. Otherwise, it's okay. Yeah. Thank you. Ma'am, please come. Okay. Okay, thank you. Thanks all for your time. Yeah. Thank you. Thank you. Thank you. Thank you all.
Thank you, Ms. Padmini, for the inspiring and practical advice. To present the memento, I now invite Mr. Sanjay Roy to the stage.
My pleasure, sir. Thank you for the opportunity. Guys, can someone just come take a picture? Oh, yeah, she's okay. Thank you so much, sir. Yeah. Thanks, sir. Yeah, thanks for your time.
Up next, we have a leader with deep expertise in platform engineering and cloud transformation, having held key roles at both Amazon and AWS. Today, he serves as a senior cloud engineering manager at Serverless, driving innovation and large-scale cloud adoption. He'll be taking us into the world of serverless with a session on Serverless 101, the what, why, and how of fast, showing why it become a game changer in modern applications. Please welcome Mr. Roy to the stage.
So good evening, everyone. Or I would say good afternoon. Sorry, it's 3 o'clock. So I hope everybody had their lunch. And who all are not feeling sleepy? Raise your hands. Okay, only one person is not feeling sleepy. So okay, people are not feeling sleepy. Okay, I didn't raise my hand, guys. Even I'm feeling sleepy. The food was really good. So, so when I said this, thanks once again for everyone coming to this. Coming to this session, and speaking about this, as you saw, my topic is the what, the Serverless 101, the what, why, and how of FAS. Now, when I speak about FAS, how many of you are aware of FAS? What FAS stands for? Don't tell me food as a service. We just had lunch. Yeah. Okay. So the thing is, I still remember when I was being interviewed, and this is with Amazon AWS. They asked me the same question, and though I was working in serverless, I didn't know about this FAS full form. So that was and being in this industry for over 20 years, yeah, that was something that was quite unique for me, not knowing what exactly this meaning, the word stand for. So today I will start with with some basics. What FAS stands for, which service actually correlates to FAS, what FAS does. And if I go to the next slide. These are practical hiccups when you have the live demo. So yeah, see, somebody else's it works. Hopefully, I have to have a separate hand. So guys, I just keep the agenda so that you know that before you fall asleep, which slide you need to fall asleep. That is most important. So I'll just go ahead with what is serverless and FAS, why it exists, the short story, how Lambda works in practice, the design pattern. This is something my favorite because this is where I would speak about the actual use cases that we have in the industry that we use. Because this is something when you build, as Padmini ma'am also spoke about, right? The certification itself is not important. You also need to have a lot of practical knowledge or whatever whatever projects you are doing, it should solve some practical use case. So please remember this in mind. The cost model, definitely how much does it cost when you build a serverless model. The guardrails, the build checklist, what checklist you can take back and what you can do from, let's say, Monday and tomorrow is a Sunday, enjoy that. And some use cases which we have used, or plus what we have seen when I was working with Amazon, and a small demo if I can give you of what exactly the latest things that have made life more easier for developers and which would also make it for you guys. So if I go to the next one, oh, it's going on the other direction, sorry. Yeah, so just raise your hands or just tell me what do you understand by serverless means no servers at all. Is it true or false? False, okay, people are not sleeping, so yes, true. No, it's true means it is false. So the term serverless means that your code runs on servers, but you don't need to provision or manage those. Basically, your underlying infrastructure, everything is being taken care by the vendors or the platform. And it works across many services. As I said, like compute, storage, your database, API gateways. This is again another serverless resource. Billing is automatic and based on the usage. When you talk about serverless, your billing is something as, it's basically as pay as you go. The more you use, the more you pay. So it doesn't, if it's lying idle, you don't have to pay for it. Next is server exists but stays invisible to the users. Basically, as I said, compute, you don't worry about what is exactly happening at the back end. You write a code, let's say it's a Lambda code, and you run it. When you run it at the, I would say at the back end, there is a container which gets instantiated, created, and the interpreter, like if you're running a code in Node.js or Python, those interpreter gets invoked and your code gets run. So this is what we have here. And the next thing, sorry, I'm always messing up with this thing. Okay, function as a service, what exactly it is. I'll just go very quickly around this because there's nothing much to know, as we already, you people have known. So function as a service lets you run small bits of code, which is basically called function. Now, in response to the event, okay, there's always an event that is happening at an end. Something comes and hits those, like something is invoking those functions. Those are called events. So basically, when I speak about this, you write the handler, the cloud runs it only when it needs and scales it up and down. So that is how it is done. So AWS Lambda basically utilizes this idea. When you talk about fast, the first thing that comes to mind, should come to mind, is Lambda, AWS Lambda. Lambda is a serverless concept, and this is also known as function as a service. So that was a question that was asked to me. So when I was told to take a talk here, this came to my mind, okay, when I went for an interview, so when they asked me this question, though I had worked on Lambda, I didn't know this was correlating to FAS, function as a service. Now what do you see here? You upload a code to Lambda. Basically, it set the code to trigger from an event source. I'll speak about what kind of event source we have. Code runs only when triggered. Code will not run. It will lie there on your machine. It will lie there on the system, but it will not run until and unless it is invoked. And the next thing is you pay only for the compute time you use. Basically, whenever the code is running for that particular millisecond or for that particular memory that it is taking, I will show those calculations also. So that is when you are going to pay for that particular service. Otherwise, there is no cost. And it's, I would say it is so successful and so widely used service because there's a lot of, even as a student, you don't have to pay anything. I'll come to that point where how you can use Lambda service without paying anything from your pocket. And you can run live projects and I would say real-time projects on this. Next is basically Lambda, what it is, high availability. So when you are invoking a Lambda function, writing a Lambda function, it is available across multiple availability zones. When I say availability zone, it is in different regions across availability zones, so that if something goes wrong with one zone goes down, zone goes down, you have the function still up and running. The next thing is automatic scaling, based on your request, based on your, I would say, the kind of request that's coming in. If it is one request, one Lambda function, if you have 1,000 requests, 1,000 Lambda functions would be invoked. And these are concurrent ones, all at a time. Then cost effective, as I said, you pay as you go. It's very, very cheap. And the next thing is built-in fault tolerance. When I say built-in fault tolerance, this is basically where you have any errors, it will do a retry. for those errors and make sure that you have a graceful exit, or it will check for those problems and the retries for those errors. Next thing, if I go here, okay, this is a question, more of an interactive quiz. Which of this can trigger a Lambda function? Which one is the answer, guys? Okay, everyone. So I cannot give any prizes. Yeah, I know almost. I don't have enough to provide. So yeah, any one of them will give this. But remember this file upload to S3. If anybody is thinking about Gen AI, agentic, what we are using in the practicality, this first one is very, very important. Doesn't look much, but I'll give you practical use cases, how we are doing it in our company. It started, people think very big when they think about AI and agentic AI, but in practical use cases, POC, everything works. You can do anything in POC, but when it comes to production level, where you are running in production, I think the first one is my favorite, where you are just uploading file to S3 and I tell you how it works. Next thing is just about the core components that we have. You see a Lambda function here. It gets invoked because of an event source, which is basically an optional response that comes up. And you have a function code. This is where your actual code gets into. So if you talk about the actual code, it can be either in Node.js, it can be in your Ruby, it can be in Python. You have Java also available, but that depends on, you cannot run it in the console, in the sense that AWS console, the code is not supported. For that also, I'll show you a demo how you can get it done. And this can connect to all the different AWS services. Next is, when I spoke about the event source, if you see here, I spoke about the event source out here. This particular event source is basically a user initiates an event by performing an action. It can be any kind of action. As I said, you upload a file to S3 and it invokes a Lambda function, which will go and do something else. This particular event will be triggered. The trigger alerts the Lambda of an event that needs to be responded to. So it's basically a connection that is happening where your Lambda is looking at an event and it needs to respond to that particular event. Lambda responds to the event trigger and runs the code. So basically there are 3 steps that's happening here. One is event source, one is AWS event, and the other one is Lambda runs the actual code. This is what is happening. So if you see here, okay, I think the other slide went there. So why does this exist, first of all? No, 1 second, sorry. I think I have to do something here. So if I click on this trigger, it shows actually the common event triggers you will use. So basically these are different things that we use. I think in the morning, Ashwin has already spoken about this. So this is basically the API gateway. You have a REST or HTTP API, you have S3 events as I spoke. SQ and SNS, I think you already spoke about this in the morning for async messaging, DynamoDB streams, Event Bridge. Everything has some use cases. So when I speak, go to the further slides, I will talk about those practical use cases of each of them, how to use them in your projects and how to use them in your daily activities. Yeah. So next is why it exists. So when you speak about why it exists, see, if in 2006 EC2 came into existence where you manage the instance, though it's not the first service, but that is where the compute comes into picture. When you talk about serverless, it's all about compute. And then in around 2009 to 13, you had auto-scaling and managed services, which reduce a lot of underlying infrastructure problems, but still did not take it from the developer's perspective. 2014, where Lambda came into picture, where you write code and AWS runs it on demand. That is where it took a lot of, I would say, headache or a lot of overload from the developer perspective. And then, in today's date, we have event-driven apps scale from 0 to 1,000 automatically. So when I say event-driven, this is what the next step for Lambda. And the next one that I have not written, but still it is something that's going to come, and I think you guys would have known, it's the agentic serverless AI. So agentic serverless is something that's going to happen. AWS is currently working on this, so there is nothing written about it, in the sense they have not published it yet. So that's the reason I've not given it here. But yeah, it's still, when I say today, take it as of 2025. So next is, yeah. So key limits you should know. There are particular limitations that we have for serverless also. Remember one thing, you write a Lambda function and it times out in 15 minutes. That if your Lambda function is quite big and it takes more than 15 minutes, then do not do that. We had a practical case where one of our Lambda function was taking more than 15 minutes and it would fail in production. It didn't happen in non-prod environments. It was happening in production. It took us I think 3 weeks to figure out why in production it was failing, but not in non-product. So I'll come to those use cases. So these are the very important thing. Any Lambda which takes more than 15, the way we did is, frankly speaking, we couldn't figure out why it was happening. There were different things because it was invoking a lot of different, I would say, resources, services internally. So we had to migrate that Lambda function into an ECS container. So it was running in a container service instead of directly running it to save from there. Cold start, it's another concept that we have in Lambda. Is whenever you invoke the first time you invoke a Lambda function, it has a the first time it has some kind of a delay, which is called a cold start, and which adds on a latency. So I have a slide for this also, which I'll discuss. Then you have deployment packages. This is the max size. As you see, one package of Lambda function can be maximum 50 MB. When unzipped, it can be 250 MB. That's the limitation. You have multiple layers. I think 5 layers that you can create. 50 MB zip size of each. And function concurrency limit. As I said, for each function, 1000 execution environments every 10 seconds. So you have a limit that you can have. As I said, you can have 1 to 1000. That's a concurrency limit that is given by default. If you need more than that, you have to go to AWS support, and based on the request and your use case, they would increase the limit. Next is, as I said, it was cold start. So this is the difference between a cold and a warm start. Cold start is basically what happens when you do a Lambda function. You start, you download and extract the code. Sorry, I'm coming in between this. So you have a container that gets started. You have the runtime bootstrap, which is basically whatever language that you have your Lambda running in. Maybe you've written your Lambda in Python, in Node.js. Those interpreters will be running, and the code execution will start. So this is basically a cold start, where whenever the first time a Lambda is invoked or a Lambda is not run for a very long time and it has to run it, these are the steps that happens. But your Lambda is already invoked and it is already running, then you directly, so this is the latency that you have, maybe in milliseconds. It's not quite big, but if you have a use case where you cannot even think of this much milliseconds of delay, then you need to warm up your Lambda functions. So it should be in a pre-warm state, from where you can run the execution code directly, and it will invoke those Lambda function and it will call those services. Next is permissions. This is very important, guys. When you run a Lambda function, remember every Lambda function comes with an IAM role. A role gets assigned to a Lambda function by default, or you can use your own Lambda role to execute a Lambda function. And this is a list privilege. What do you mean by list privilege? It means it will have some kind of a guardrail. When I say this guardrail, it will have some kind of permission guardrail that nobody other services or which services need to use this Lambda function. So your function can only do what the role allows. This is the first. Grant minimum S3 or DynamoDB permission or for logging purpose. Use separate roles per service or function when possible. So this is what we have here. Next is CloudWatch logs and metrics. This is for the observability part. So how can you make sure that monitoring comes into picture? As she mentioned, we have Splunk, we have all the other monitoring like Prometheus and all. But here, for the default one that is given by AWS is CloudWatch that you can use. You can have alarms for error rates and P95 and P99. How many of you have heard about this P95 and 99? So these are latency checks, guys. Like it says P95 means 95% of my requests should go without any latency. 99 means 99% of my requests should go through without any latency, that I can only have 1% of latency. Next is X-ray. X-ray is another form of monitoring for traces across the services. You can also use Cloud Trail. I've not written it here. Next is patterns to build. This is very, very important. The use cases that I spoke about, I will talk about this here. So treat the patterns as something that you don't, I would say you're not reinventing the wheel, but you're using something that is already existing. So when you talk about it, it's like treat it like your starter kit. So you use reusable blueprints, what is already existing. Based on that, you build on top of those patterns. And you avoid reinventing, as I said, architecture every time. Instead of pick the pattern that matches your trigger, data flow, and constraints, you actually use, based on the use case, you define which pattern to choose. So if I go to the patterns, I have different patterns here. So if I go to the patterns here, so I'm starting from pattern number 5. I'll come from the least to the most important one. So you see here how it happened is API gateway integration. You see here, so you create a Lambda which connects to your S3 and your DynamoDB. Let's say 3-tier application. Now Lambda itself, if you invoke it, the Lambda, and you put it in front of the world, you are exposing a lot of security vulnerabilities in front of it. To make it secure and everything, what we do is next step is we bring an API gateway. It gives an HTTP endpoint. It gives you a secured way of connecting to those Lambda functions, and the user would be able to get those endpoints where they can invoke this HTTP request, they send a response, and the Lambda gets invoked, does the stuff, and sends back the response via the API gateway itself. And the next one when I speak about is serverless cron jobs. So one good thing about Lambda is, let's say you want to, somebody was talking about the deployment part. So you want to run your jobs, you want to schedule your jobs that should run, let's say you want to have a dashboard that should be refreshed at a particular point of time on a day, or some batch job that should be run. So this is where your cron job comes into picture. So you have an event bridge that actually, when I say time-based event, that happens via the Cloud Watch events. I have not given it there, and it triggers the Lambda function. This is another use case, guys. Remember this. If you're scheduling, use event bridge along with CloudWatch events and to invoke the Lambda. This is another one, practical use case. Then you have the event processing with SNS and SQS. So what happens here is, when we started off with Lambda, you have a SNS is basically simple notification service which acts as a publisher and subscriber. In this case, your Lambda is a subscriber which is actually subscribing to the events that is coming up from the notification service. When a request is publishing something, Lambda is taking it from there. But this itself is not a great functionality. So what you bring in here is you use SQS, where you store all your messages in the queue, and then it's called simple queue service. Based on this SQS, your Lambda can get invoked and it can trigger the functions. So you publish something via SNS. SNS is basically a publishing subscribing model, as I said, as a message broker. It will send it across to SQS, and from there your Lambda would be getting invoked. And this is required when you do any kind of notification services. Next thing is, this is the most important one. As I said, this is my favorite, is file upload using S3. So why I'm saying this is very simple. You have a file, you have a photograph, you have anything, any data, and you use S3 to upload the file. Once the file gets uploaded to S3, this triggers an event which goes to the Lambda, and Lambda processes the event. Now I've not written here what happens after that. So in a practical use case, guys, today coming from the healthcare industry, this particular photo is not a normal hour photo. This photo can be X-rays, ultrasound reports, everything of the patients. And this photo gets stored in the S3 bucket. And from S3 bucket, this gets triggered to the Lambda, which is looking into image processing. This goes to SageMaker, this goes to Bedrock, and they use LLMs to transform this image, bring the data out of it. Thousands and thousands of images are being captured. So we use LLMs like CNN to capture the data, and to, I would say, once we have this data, we do a lot of, I would say, like, once we have this data, we do a lot of, how do I say, we say epoch, but it is basically like a lot of iterations and testing is done, or validation is done on this particular data. So this is a very important and useful use case, guys. If you are planning to use serverless for your projects, or finally your projects for a real use case, think of this. This is the most easiest, most cost effective, and the best thing. Behind Lambda, you can use any service, you can use a SageMaker, you can use Bedrock, whatever it is, but you can use even Kinesis also to stream. So think about it. So this is my favorite, and number one why I have kept this is because when we started, that time we didn't have this something called as step function. We didn't have this step function. What we had is normal Lambda, and we used to connect with other Lambda. Right now, step function is, see, I'm just talking about, let's say, a card where you have the PIN validation service, and you have basically does a credit card validation. If you're giving a wrong credit card, it will go and say it's failed. But if you are basically putting one more Lambda here, A step function, I think somebody already showed that previously. So step function is basically when your one lambda is calling the other lambda with different steps. And if this is success, let's say the credit card is validated successfully, it comes here, it looks into the transaction and sees what kind of service the card is, whether it's a Visa or MasterCard, and based on that, it will take some action. And if it's successful or failure, it will go to the end step. So step function is like you're orchestrating all the lambda functions together to do a particular set of logic. So all the business logic runs behind, which will take care from one to the other. And this is what we had for the 5 practical use cases. Make sure you use it. Next thing is how to choose. This is a cheat sheet, guys. Take a photograph of it if you want. This is very important. Like everything that we do, I've just given it here. HTTP request. If you need an HTTP request, normal one, CloudFront plus S3, which if you are building a static UI, it is API Gateway, Lambda, and DynamoDB. For a file landed in S3, upload S3, event triggers to Lambda, transform validate, write to S3 or DB. When it's a transform validate, this is where you can use different AI tools. Slow work, if you don't need that many high latency, you can use API, SQS, Lambda, DB. Another real-time feed, if you need real-time data processing, as I said, Kinesis or DynamoDB streams with Lambda, which will alert the database.
Guys, the workshop is going on the DevOps room. If anybody have you registered for the workshop, you can move to the venue. Since it is going parallelly, we have arranged in the DevOps room. Okay?
No worries. No problem. So I get 5 more minutes extra, right, for this. See, that is why I did. Okay. So next thing is, as I said, if you are on a schedule, use EventBridge schedule. Webhooks, use API Gateway. For orchestration workflow, as I said, use step functions. So this is a cheat sheet of whatever you require. Next is, as I said, the event-driven architecture. This is basically a normal slide which says about the architecture. Like all the things that I've said just now is just in the architecture way that I have given it in the form of a picture. So this is how your S3 bucket, Lambda, SQS, everything that's converter will get connected. This is the client, and this is the end producers when I'm talking about the event bridge. So this is the architecture diagram. This will also help if you are planning for your projects. Make sure it doesn't have to be all the components, but you can pick and choose the components that you require. Next is the cost model. When I said it's very cheap, guys, just think about it. I'm not going with this compute cost, but it's so cheap. See, you require only 20 cents per 1 million requests. Remember, 1 million. But before that, read this. First 1 million free monthly. Every month you get 1 million requests free for your Lambda function. So it's not. There is no way that you would invoke this. If you have run a recursive function that is doing it, that's a different thing, which doesn't happen. But otherwise, you're not paying anything for it. Second is compute bill. It's built at GB second rate. So when I say GB second, if you see this, 1 GB of memory for 1 second is equal to, see the cost. It's 0.0000116. After 5 zeros, it's coming as that much. So if you're running at 1 million function calls in Lambda, each taking 100 milliseconds, and using 512 MB of memory, each is taking 512 MB, okay? Your AWS bill for that workload would be about $1. Let's say in today's date, it's 1.03, let's say somewhere around less than 100 rupees. So your entire project can be built on a 100 rupees thing. Plus AWS gives you credits, $200 credit they give you. So think about it, $200 credit and you're getting $1 for just doing this particular stuff. So I'm not going, it is just multiplying all those compute costs. So that is how the math is. So remember this. I would suggest when you're building a project, use serverless, because that's where you can do a lot of POC. You can fail, you can make mistakes, but you're not paying anything from your pocket. The moment you use any other services, it becomes very cost. You have to be very careful about the cost. Even if you build an EC2 instance, other than T2 micro, you know what happens, right? You have to pay for it. So think about it, and let's go to the next one, Lambda performance optimization. This is basically, I'm speaking about the right sizing memory and everything. Like if you want to right size the memory, use Lambda power tuning. Avoid unnecessary VPCs. So only use VPCs is accessing private resources, otherwise do not use. These are something that will help you to optimize your Lambda and optimize the cost. If you're building a project in serverless, these are the things that you should keep in mind. Reduce cold start if you are not provisioning, like there's no you don't need a concurrent kind of an access or use provision concurrency to pre-warm up function. That only happens if you have too much of load coming in. For a project, I don't think that is required. For a real-time use case also, I have never seen, like it's a very rare cases where you'll have so many requests coming in until you have that many users invoking the same Lambda function. And optimize dependency, use Lambda layers. As I said, maximum of 5 layers can be created. You can use those layers. But there is but keep the packages less than 10 MB zipped. That is what it says, because the time to load those packages also is with all the dependencies also takes time. Next is when not to use Lambda. As I said previously, we had a use case where our Lambda was failing. It was timing out because of more than 50 minutes. So jobs which takes more than 50 minutes or heavy streaming, don't use Lambda. These are the use case that you should not use serverless for. For very large payloads, which is greater than 6 MB sync. When I say this async, what happens is you have huge dependencies, huge libraries inside your that needs to be used, invoked with your Lambda. Do not use this. Massive OpenDB connections. Instead of this, use SQS, RDS proxy, and move to ECS or EKS. As I said, we used ECS. And ultra low latency, where cold starts are unacceptable. So when I say ultra low latency, it is a kind of stuff where let's say you're chatting with someone, your WhatsApp or anything. In that case, you don't want latency to happen, right? You're sending a chat and sending, that's the wrong thing. So that is where you don't use this kind of function. Otherwise, you'll have to warm it up. In the sense, you don't want cold start. Next is checklist. This is a practical one. Keep packages small. Lazy init SDK. I imported potency. This is basically retries. So what happens? Lambda has a good thing that, let's say you are sending today you come by auto or whatever it is, and you're doing a UPI payment. Let's say the payment is showing as hanging. It should not be the case that you click on pay again and you should pay the person and again and again. It's just a one-time of event that happens. So it takes care of that. As I said, use RDS proxy or prefer DynamoDB. Align timeouts and retries. It does that. Set alarms on errors. It does help you with setting the alarms. And I am list privileged. As I said, with the roles, it takes care of your permissions, boundaries, and everything that you use. Next thing is, this is something that I recall when this is during COVID, okay, and I was with Amazon AWS, and this was a project that was very, very close to our heart because that happened, and we were I won't say I was directly part of it, but we were engaged on this project. This was using from phone to cup, a journey board digital device. So what happened here is, people were scared to go and press those machines. These are Coke vending machines. If you can see, they vend Coke, different flavors of Coke, Coca-Cola company, different flavors of those. And people were, due to hygiene issues, people were scared to do that. So what Coca-Cola bought in, AWS did the entire stuff was, you scan the QR code on this machine. It is done on the go. You don't have to log in or anything. And you have your entire, I'll just talk about it in the next slide. See, this is the architecture. So as a user, you scan the QR code. So you have a QR code connection. And the next thing is, it drives the cloud-driven logic. So it goes to only 3 things for use, guys. API, gateway, AWS Lambda, and DynamoDB. Nothing more than that. So nothing more than that. With these 3 things, they were able to scale this up. And I'll talk about this. The real-time controls were given to the customer, whether they want to send a pour or a stop request, that when they want us to be stopped or when they want to be poured on the glass, and show real-time status, that how much the glass is full or not, how many glasses are available, how many they can pour in. This is what you have with no physical contact. And if I show you this, and this was directly using IoT, it was connected to the vending machine, the dispenser machine. And if you see here, just a smartphone QR code scan, cloud-based, cloud backend ensures safety, speed, and reliability, designed for pandemic safety and customer convenience. This was done. Look at this. By the end of 2020, Coca-Cola had upgraded to support the touchless pour system, and in US they did it for 52,000 freestyle machines. None of these machines has this, but across all the machines they did it, and across globally outside US, more 8,000. So total 60,000 machines were made, I would say, serverless. They were all done touchless, using only Lambda, API gateway, and DynamoDB. So think about the scale that it can be done. So when you're looking for your projects or you're looking for something that you need to implement, think of all these use cases. Go through AWS blogs, you have it there, and see how you can manage this. Because these are no, if they would have not done it, nobody would have said, but only these 3 components you can build something like this. Just because a company like Coca-Cola and AWS has done it, so it became a real case a real case study. So this is what is very important, and we really liked it because that was for us also it was a very big thing, because the kind of scaling that happened here. And when you say this, you're talking about 52,000 machines, but how many ports happened? That was in millions. When I say ports, per cup, millions of cups were getting dispensed, because people are scared to touch anything, and here you're getting everything without touchless. So this is what I really like this case of serverless. For me, there are many other ones, but this was something that I wanted to highlight. With only these 3 components, you can achieve such a big thing. And it's a revolutionary thing which is being used everywhere. And so I'll just show a small demo, guys, which I had built. So this is basically effortlessly moving between AWS console and IDE when working with AWS Lambda. So basically what happens is, when you're working on AWS Lambda, you know you have to go to the AWS console, write the Lambda code and deploy it there. But the latest change that AWS has made, the new thing is, you can pull that Lambda code to your VS Code in the local, just making sure that you have your toolkit and AWS toolkit and installed, and VS Code definitely needs to be installed. Once you do the authentication, you can do it in your local and you can publish the code or deploy the code directly. So I'll just show the demo here, 1 second, if it comes up. Yeah. So if you see this, guys, just play this. This is my demo only. The sound will come, so otherwise I'll go through it. You can see that I created a time difference Lambda, just a basic Lambda, and you can see the code there. The code is nothing but just a hello from Lambda and nothing else. So you can see here there's something called as Open in Visual Studio Code. Nowadays you get that. If you click on this, I don't know if it's clicking or not. Yeah, it is going on. So if I click on this, you would see sorry. Okay. So once you do that, you get this pop-up in your what do you call VS Code. You click on open. Your VS Code should open now. So yeah, that's what happened during demo. Yeah. So this is your VS Code, guys, and if you see in the VS Code, it's asking for the AWS tool extension to be opened. So when you click on open, this is interesting. It got stuck there or something. Yeah, it's still going. Yeah. So if you see here, it came here, and it is the particular Lambda function that you see here that got imported, and it is in a temporary location. Okay, it is not in a main location. It is in a temporary location in your system. And I just take this code, I remove this code, and I place a different code which shows the time difference between New Delhi and London. I think that was the one that I had put. So if you see here's the time difference between where it is, New Delhi and London. So this is the time difference that I'm just showing. This is not to show how the code works, but to show that if I make any changes here, I can go and it shows as deploy. Would you like to deploy these changes to the cloud? Now I don't want to deploy, because here what happens here is, if you see here, there's something called as import. It could not be resolved. There is an error here which this particular library is missing. Now I have to get that dependency. So what I do here is I open the terminal. I open the terminal and I just do what? Today morning you guys, whoever has attended, is pip install. Yeah, it's pip install that particular package in this particular folder, because it's a temporary one, and it will go and install this particular package. Once this particular package is installed, you see here, first you only had this Lambda function, now you have this packages also. And you see there, it says, do you want to deploy it? So now if I deploy it, it will not only deploy the code, it will deploy the code along with this packages. The entire dependencies will be going to your AWS cloud. So you don't have to worry. So everything can be done in local, and then you can package the entire stuff and send it to your AWS console. So now if you see here, it is uploading. I've clicked on deploy, saying archiving. It is archiving the Lambda. It will zip the Lambda, and then it will publish it there. So let's wait. Uploading, it's uploading the archive. And it says uploaded Lambda function. time difference. It says the same Lambda function has been uploaded. So now if I go to AWS console, there's my old code. I just go and refresh it. And if I refresh, now I should be able to see my, this is the same Lambda function time difference. It's still loading. And here in the Lambda, you can see, this archives, the zip files have come here, and you can see the entire code here. So in your local, you can start developing. You don't have to worry about doing everything here and clicking on deploy and testing, nothing. Everything can be done on your local, and you can directly deploy it in AWS. This is a new functionality that has been provided. It really helps for developers. Is the best thing that you can do. So I think this is what I had for today. Any questions, any concerns, please let me know. I think I'm done with the demo also, and I'm right on time. So thank you so much. Any questions, guys?
Thank you, Mr. Sujay, for making serverless both clear and practical. Now I invite Ms. Navi.
I think somebody has a question.
Oh, yeah, you can go on.
So since you shared Lambda can handle multiple events also, right? So how can it withstand multiple load balance? Is there any default load balancing strategies in Lambda?
Yeah, there is default load. As I said, Lambda has it's deployed across multiple availability zones.
Also, they rely on separately AWS load balance.
No, you don't have to rely. By default, as I said, by default it gives you that high availability and your fault tolerance capability. So you don't have to worry about it. Serverless means the underlying infrastructure will take care of everything. If you have too many loads, that is what I said. When you have too many loads, you cannot use Lambda by itself. You use API gateway. Today you saw the Coca-Cola thing, right? Think at one point of time how many people across the globe or across USA is 52,000, how many people would be pressing that button? So it is able to take that concurrent load, right? At one point, maybe let's say at the worst, 1,000 people are pressing the button. So you don't need a separate load balance. It was only with those three things that it was able to do, because by default it provides you that function. Yeah, because you as a developer should not be bothered about anything about the infrastructure. That is the idea of serverless. Cool. Yeah, I think we're done. Any other questions? Please come back to me. I can.
Thank you, Mr. Sujay, for making the serverless both practical and a good session. I'd like to invite Ms. Navina Ravi for giving the momentum to Sujay. Now we close this practice session on knowledge graphs, how to connect data meaningfully, revealing hidden relationships and drive intelligent applications. Our speaker is a lead consultant with the decades of experience in enterprise data and AI platforms. Please welcome Ms. Navina Ravi, lead consultant at AstraZeneca and AWS Cloud Solution Architect.
all. We just start the session till the slideshows are getting connected. In this session, I would like to share my knowledge and my learnings from my professional page about knowledge graph. So knowledge graph is not a new topic. I think most of you would have come across it during your college days when you are studying. For professionals and for students, I think all of you must have gone through it as a part of one of your paper like data graphs, data graph database, or computing with graph structures. So to introduce myself, I'm Navina Ravi, and I am playing a role of enterprise lead with AstraZeneca, and this session is purely based on my professional experience, and I would like to share my learning journey and also help you realize how a knowledge graph plays a potential role in AI. So how many of you remember graph database when you were studying in the college? Is there anyone? Apart from that, so today most of us we are been using AI at one point of time or other. I mean, for all our daily activities, we have been using AI and giving prompting. So what do you think is behind the scenes that help us create a personalized experience for us? Anyone? How many of you understand like there is something going behind the screen which is able to evaluate our choices and is able to predict our what is required for us on day-to-day basis and giving us some promotions, or it is telling us do you want this product, or do you want to choose this, or do you want to connect with this friend, all that. So behind all these we have data representation as knowledge graph. So in this session I'll try to start from basics and help each one of them understand how a data about us or how a generic data gets changed or classified as a knowledge graph which is consumed by multiple AI services. So to start with, we have all of us are familiar with database, and we have typically two types of database. One is relational and other is NoSQL database, which is already covered in our previous sessions. We have already seen relational database and NoSQL database. So relational database, to start with basics, it has the tables and we store data as rows and columns. Whereas in case of NoSQL, we do not have any specific format. Multiple types of database comes in the category of NoSQL. So in the NoSQL, one of the prominent databases is graph database. So how many of you are aware of why we have been using graph database instead of relational database for all our AI or any personalized experiences? So I think the crowd is good. So now with relational database, we have a very standard or definite structure. So for each of our primary data or primary key, we need to have a set of fields which is fixed. However, in case of NoSQL, we do not have such restrictions. So that is one of the main reasons we are going to NoSQL. These are some of the different types of NoSQL database. In this session, we will focus primarily on graph database. which forms some of the building blocks for AI and analytics. So graph database stores the nodes and relationships instead of tables or documents. And in graph database, we can store the data as we draw in a sketch. So mainly we are using graph database for the purpose. So I'm just starting with the basics to understand why graph database forms a building block in today's AI. So when we want to understand the relationship between two data and how they are getting related, we need to use knowledge graph, or we are using a graph database to have that. So one popular question, is this graph? Is any of these pictures a graph? What is a graph? Is any of these pictures graph? Yes, correct. I think most of the team members are listening. So these are not graphs. So basically, what is a graph? A graph is a data structure which has the vertices, edges, and which we call as nodes or relationships, and which can represent the relationship between two data. And we have all studied the theory of graph. Like a graph can be a directed graph or an undirected graph. And popularly, we have seen multiple examples of graph being represented as a network of cities, how we track and travel from one city to another city. So all these examples we have seen. The students must be familiar with that. So that are some of the basic of graph. So now if we see this picture, so here if we see, we are seeing a graph, but it has a lot of information. So this is how AI is able to identify the relationship between multiple objects, and it is able to predict the relationship between the objects, and able to give us personalized experience, and able to create a lot of products for us. So now, have you ever thought when not ordinary graph gets converted to a knowledge graph? So that we will see in the detail. So I am trying to explain this based on my experience from a very high level overview. I think it will help each of the students when they are going to the corporate or enterprise, and when they join an enterprise, they will be able to appreciate how the entire enterprise is playing their role to convert the data they are getting from various sources into a knowledge graph that can be consumed by their AI team. So again, fundamentals of a knowledge graph. So basically, we have two types of knowledge graph, which each of the developer or AI developer or data members should know. One is a resource description framework graph, and another is a labeled property graph. So resource description framework RDF graph has the resources as the main framework, and it is used to represent simplified form of data. Whereas in case of labeled property graphs, in the graph we can also have multiple labels for each of the nodes and edges of a graph with as a key value pair. So why we have these two type of knowledge graphs is there are multiple applications we have been using AI for. So some of them, like we have Facebook, we have Instagram, Twitter. So we have AI being used for multiple social networking. We also have AI being used for more critical applications like financial sectors and medical sectors. So primarily RDF is used for representing the social networking, used for low critical applications, and labeled graph is mainly used for more complicated real-time scenarios. So this is what I would like to share with the audience today, and this forms one of the big picture, like how data which we get from different sources for an industry get transferred as a knowledge graph, which can be consumed by an AI team. So here each of these layers could be shown as a single line in our slide, but there are thousands of teams working in an enterprise for each of these layers to ensure we are able to implement each of these layers. So coming to the first one, data ingestion. So every enterprise has multiple teams working on data ingestion, in which case we are getting raw data from different sources, and that raw data is ingested to their warehouse for transformation and also for the data quality management. So when one set of team or one group of team is working to ingest the data, there is other set of teams working on the taxonomy or ontology. So what is taxonomy or what is ontology? So these two phrases are little bit not familiar to most of us unless we keep working on knowledge graph or AI in depth. So taxonomy, you can understand it like a binary tree based graph structure. So it is a hierarchical structure, and it is also a simplified form of representing the data. Whereas ontology is a very complicated way of representing the data, which can be used for critical applications like in pharmaceutical or in FinOps or in financial services to identify the fraud direction, etc. So generally taxonomy is used as one layer of data management, which is followed by ontology, which actually is worked on by the architects of multiple enterprise, which is modified based on their own business requirements, and they come up with the ontology for their own application. So while one group of architects or one team of architects are working on the layer 2, we additionally have layer 3, where the data modeling and the schema creation is happening by another team of enterprise architects in an organization, where they create the schema for the data that has been ingested, and they try to model the data so that we have the data in a specific structure, which is based on the ontology and the taxonomy. So in a very basic terms, we have tables and rows, and we have tables and rows. So when a data from a traditional database gets converted to this format, what happens is when we are applying this taxonomy and when we are applying the data modeling schema creation, this data actually has a lot of value addition and lot of knowledge based on the enterprise applications. Next, we have the fourth step, data quality management. This is where multiple engineers play a role in an enterprise. We call it as a data transformation, in which each of the data that is present for an enterprise is reviewed, or they have this data quality management in which the data is cleaned up and data is segregated into multiple layers so that it is suitable for a creation, for a graph data creation. Then the final stage is graph data instantiation, for which we have multiple graph databases available in market, including one offering from AWS Neptune. So for a graph data instantiation, we need to have all these 4 stages completed, so that the output of that, when we are giving it as an input file or a input to a graph database, it creates as a knowledge graph. So why we call it as a knowledge graph is because that graph is able to help us interrupt the knowledge or what is required for our enterprise business requirements. A very basic example, when we have Facebook giving us a lot of recommendations, they process all our data and store it in a form of a graph, where it will say where they store like person A is related to person B as a friend, as a co-worker, or as a family member. So when they want to give a recommendation, they can recommend all their first circle or all their second circle based on how they are placed in the graph. And one of the most important concept here is when we are creating a knowledge graph in an enterprise, we should ensure we follow this FAIR data principle: findable, accessible, interoperable, and reusable. So when any organization or any team is creating a knowledge graph, they create chunks of graph for different purposes, which should be able to be reused by other departments. So that particular graph must be findable. For example, a set knowledge graph for countries, which has different country details, must be reused by other teams working on continents, and they must be able to interoperate to form a complete graph of world map, and they must be reusable. For example, the world map should be used for multiple purposes, for storing the geological information or any physical infrastructure requirements and medical information, etc. So due to the time constraint, the last one is we are speaking in the serverless track, and we have got many previous sessions on how serverless was helping us. So we also have a service, AWS Neptune, which is a serverless graph database from AWS. So when we provide data suitable, following all the process steps, with the data modeling and with the semantic details, we can provide, and we provide it as an input to the AWS Neptune, we get the knowledge graph instantiated or created that can be further used in AI. That's all I have, team. I think we are closing the session. Any question answers? Thank you, team.
Thank you, Ravina, for the insightful closing session. To present a token of appreciation, I would like to invite Mandeep Singh to the stage. Mandeep Singh, sir.
I request Mr. Ashwin Armugam to come onto the stage. I call upon Mr. Sujoy Roy to give a token of appreciation for Mandeep Singh.
Pillai. Yeah. Done.
I request everyone to move on to the panel, to AV Hall 1 for panelist discussion. Our volunteers will be outside to guide you to the hall.